On an ordinary afternoon, an airliner leaving Miami can climb east over the Atlantic, cross the waters associated with the Bermuda Triangle, and arrive hours later without anyone on board thinking twice about where they have been. Cargo ships do the same thing below. Cruise ships leave Florida for the Bahamas. Tankers follow established routes through the western Atlantic. Fishing boats move between islands and continental ports. Every day, thousands of people pass through a region that popular culture has spent decades describing as one of the most dangerous places on Earth. Nothing happens to them. There is no sudden wall of fog, no spinning compass, no strange light beneath the water. The ocean looks exactly as an ocean should look, blue in the shallows, darker where the seafloor falls away, broken by whitecaps and the occasional line of a ship moving toward the horizon. And that ordinary appearance is what makes the Bermuda Triangle such a strange place to begin a story, because very few regions on Earth have acquired a reputation so completely disconnected from what most people actually experience there. Ask someone to draw the Bermuda Triangle, and they will probably know roughly what to do. Put one point near southern Florida, usually Miami. Place another around Bermuda, isolated far out in the Atlantic. Drop the third toward Puerto Rico. Connect them with 3 straight lines, and suddenly, an enormous piece of ocean becomes something more than ocean. It becomes the Bermuda Triangle. That shape has appeared in books, magazines, documentaries, newspaper illustrations, and television programs for generations. It has become so familiar that the triangle feels almost like a natural geographical feature, something comparable to the Caribbean Sea or the Gulf of Mexico. Yet there is a problem. No universally accepted official boundary exists. The United States Board on Geographic Names does not recognize the Bermuda Triangle as an official geographical name, and the US Coast Guard does not treat it as a distinct hazard area. Depending on the author, the map, or the story being told, its borders move. Some versions stretch farther into the Atlantic, others reach deeper into the Caribbean. Incidents that occurred near the supposed edges are sometimes included, while others are left outside. The most famous mysterious place on Earth begins with a surprisingly basic uncertainty. Nobody can agree exactly where it is. That sounds, at first, like the sort of detail that might end the mystery before it starts. If the boundaries are invented, perhaps the entire thing is invented too. But that would be far too simple. The lines may be human creations, but the events associated with them were real. Ships really did fail to arrive. Aircraft really did disappear. Families waited for people who never came home. Search crews really did fly over empty stretches of water looking for oil slicks, floating wreckage, lifeboats, wings, hull fragments, anything that could explain where a vessel had gone. Some of those losses were eventually understood. Some probably have explanations that can be reconstructed from weather, navigation, mechanical problems, or human decisions. Others remain unresolved because the evidence required to answer the final question was never recovered. The United States Navy still lists the disappearance of USS Cyclops in 1918 and Flight 19 in 1945 among the historical cases most strongly associated with the Bermuda Triangle, even while rejecting the idea that the region possesses some unique supernatural danger. That distinction matters because the Bermuda Triangle has always existed in 2 different forms at once. There is the triangle of popular imagination, a place where compasses supposedly spin without reason, aircraft vanish from clear skies, ships disappear in calm seas, and strange forces wait beneath the surface. Then there is the real Western Atlantic, an enormous, heavily traveled ocean region shaped by powerful currents, tropical weather, reefs, islands, deep water, shallow banks, busy shipping routes, and a long history of navigation. For decades, those 2 versions have been blended together until it has become difficult to tell where the ocean ends and the legend begins. Even its size changes depending on which map you choose. Draw the familiar triangle between Florida, Bermuda, and Puerto Rico, and you are enclosing hundreds of thousands of square miles of ocean. That alone changes how the mystery should be understood. A small patch of sea with an unusual concentration of disappearances would be one thing. A vast region crossed continuously by ships and aircraft is something else entirely. Every additional mile inside the boundary creates more traffic, more storms, more mechanical failures, more navigational mistakes, and more opportunities for accidents to occur. But once a region becomes famous for accidents, something unusual happens to the way we remember those events. A vessel lost elsewhere is a maritime disaster. A vessel lost inside the Bermuda Triangle becomes evidence. That process did not happen overnight. The triangle was built gradually, not out of one great catastrophe, but out of stories that accumulated over decades. A naval ship vanishes. Years later, aircraft disappear. Another airliner fails to arrive. A tanker is lost. A magazine writer notices the pattern. A book expands it. Television gives it images. New incidents are added to old ones. Details become simplified with every retelling. Weather disappears from some versions. Technical problems are forgotten. Search areas shrink. Distances become vague. The absence of a wreck becomes evidence of something impossible, rather than evidence of how difficult the deep ocean is to search. Eventually, the stories become so familiar that the triangle begins to feel older than the events themselves. But it is not. When USS Cyclops disappeared in March 1918 with 306 crew and passengers aboard, no sailor on that ship believed he was entering something called the Bermuda Triangle. The name did not yet exist. When 5 US Navy Avenger aircraft left Fort Lauderdale on December 5, 1945, the men aboard were beginning a routine overwater navigation exercise. They were not flying into a world-famous paranormal zone. The modern idea of the Bermuda Triangle would be constructed around losses such as these later, after writers began connecting events that had originally been investigated as separate accidents. The Navy still describes Cyclops as the largest loss of life in US naval history, not directly caused by combat, and Flight 19 remains unrecovered. Those are extraordinary historical facts, without adding anything supernatural to them. Perhaps that is why the legend proved so durable. It did not begin with nothing. It began with genuine absence. A ship leaves port and fails to appear at the next one. 5 aircraft leave a naval air station and do not return. Search crews cross hundreds of miles of water and find almost nothing. When evidence disappears along with the people involved, the empty space that remains is difficult for us to tolerate. Human beings prefer completed stories. We want a cause, a sequence, a final moment. We want to know whether a ship rolled over, whether an aircraft ran out of fuel, whether a storm arrived at the wrong time, whether someone made one incorrect decision and then another. When those answers are missing, imagination moves into the gap. The Bermuda Triangle became one of the most successful gaps in modern history. Its reputation grew precisely because the ocean refused to provide clean endings. A crash on land leaves a location. Investigators can walk the site, examine wreckage, reconstruct impact angles, inspect engines and instruments. The sea is different. Debris drifts, heavy objects sink, currents move floating material away from the point of impact. Depth can place a wreck thousands of meters below the surface. Storms alter the search area. Before satellites, modern radar, GPS and emergency beacons, even knowing where to begin looking, could be uncertain. A final radio call might provide a direction, but not an exact position. A ship expected at one location might have been dozens of miles away when something happened. The phrase, "vanished without a trace," sounds supernatural until we ask what finding a trace in the open Atlantic actually requires. And this is where the triangle begins to become more interesting rather than less. If all we wanted to do was dismiss the legend, we could point out that the Coast Guard does not recognize the Bermuda Triangle as a uniquely dangerous region and move on. But that would leave almost every worthwhile question unanswered. Why did these particular cases become famous? What happened to the men aboard Cyclops? How could 5 military aircraft become so confused over waters regularly used for training? Why have no confirmed remains of Flight 19 been recovered? What role can weather play in a region where tropical systems, Powerful thunderstorms and rapidly changing conditions are common. How quickly can the Gulf Stream carry debris away from an accident? Why did claims about magnetic anomalies become so closely associated with this part of the Atlantic? And how did unrelated incidents, spread across different decades and involving completely different machines, become part of a single story? To answer any of those questions, the lines on the familiar map become almost useless. They tell us where people have chosen to place the legend, but they tell us very little about the physical world underneath it. The real Bermuda Triangle is not a neat geometric shape. It is warm water racing north through the Florida Straits. It is the open Sargasso Sea surrounding Bermuda. It is shallow banks rising towards sunlight and deep Atlantic basins dropping into darkness. It is tropical weather moving over thousands of miles of water. It is one isolated archipelago, one heavily populated continental coastline, one mountainous Caribbean island, and an enormous moving ocean connecting them. The lines may be imaginary. The ocean beneath them is not. The lines may be imaginary. The ocean beneath them is not. Leave the coast of Florida, and the first thing that becomes clear is how quickly this world changes. Miami may still be visible behind you, but beneath the boat, the continental shelf begins to give way. The warm, shallow water around Florida is connected to something much larger, a moving river of ocean water flowing north through the Florida Straits. This is the beginning of the Gulf Stream, one of the most powerful currents in the Atlantic, and one of the most important pieces of the Bermuda Triangle story. The Gulf Stream does not look like a river from the deck of a ship. There are no banks holding it in place, but satellites can see its shape through differences in temperature, and oceanographers can measure water moving through it at remarkable speed. Warm water from the tropics is squeezed between Florida and the Bahamas before continuing north along the American coast. In some places, surface water can move several miles in an hour. That may not sound fast compared with a ship or aircraft, but for something floating helplessly in the sea, it is enough to completely change a search. Imagine an aircraft entering the water and leaving behind a life jacket, a seat cushion, pieces of metal, and a thin patch of fuel. Searchers arrive hours later and begin looking near the estimated crash position. The heavy wreckage may already be sinking. The lighter pieces are still moving. Wind pushes them one way, the current carries them another. By the time aircraft begin flying search patterns, some of the easiest evidence to spot may already be miles from where the accident happened. This will matter later, because many Bermuda Triangle stories contain the same haunting phrase, "No trace was ever found." But in this part of the Atlantic, the ocean does not simply hide evidence. It can move it. To the east of Florida lie the Bahamas, and here the seafloor creates another strange contrast. Around many of the islands, the water is famously clear and shallow. Vast carbonate banks lie beneath turquoise seas, in places shallow enough that the bottom can be seen from the air. Then, sometimes over a surprisingly short distance, that bright water gives way to deep blue. The Bahamas sit beside steep underwater slopes and deep channels. A sailor can pass from relatively shallow banks into water hundreds or thousands of meters deep without traveling across some vast gradual descent. The landscape below is far more dramatic than the flat surface suggests. That hidden landscape is one reason maps of the Bermuda Triangle can be misleading. From above, everything inside the lines looks like the same blue Atlantic. Underwater, it is anything but uniform. There are shelves, banks, channels, reefs, slopes, plains, and enormous depths. A ship passing through shallow Bahamian waters faces a different environment from one traveling across the open Atlantic, even though both journeys may later be described simply as taking place inside the Bermuda Triangle. Continue northeast and eventually there is almost nothing visible at all. Bermuda appears in the open Atlantic more than 600 miles from the coast of North America. Its isolation is part of what makes the familiar triangle seem so enormous. But Bermuda itself is also the visible tip of a much larger geological story. The islands did not simply rise from an ordinary piece of seafloor. Bermuda sits on an underwater volcanic rise formed tens of millions of years ago. The volcanoes are long extinct, and the islands people see today are capped by limestone, created largely from ancient marine material. What looks from the air like a small collection of subtropical islands is really the highest surviving part of a structure rising thousands of meters from the surrounding ocean floor. Around it, coral reefs became both protection and danger. They helped create the shallow, clear waters associated with Bermuda, but historically, they were also a serious threat to ships. The islands are surrounded by hundreds of known wreck sites from centuries of maritime traffic. Long before radar, GPS, and precise electronic charts, approaching a small island surrounded by reefs in the middle of the Atlantic demanded careful navigation. But Bermuda sits within something even stranger. Look at a normal world map, and seas usually make sense because land defines them. The Mediterranean is enclosed by Europe and Africa. The Caribbean is framed by islands and continental coastlines. The North Sea sits between Britain and mainland Europe. The Sargasso Sea has no coastline at all. Its boundaries are created by moving water. A huge system of Atlantic currents circulates around it, enclosing a broad region of relatively calm open ocean. The Gulf Stream forms part of its western boundary. Other currents complete the circulation farther north, east, and south. Instead of continents holding this sea together, the ocean itself does. Its name comes from sargassum, floating brown seaweed that can gather in large mats at the surface. Early sailors crossing these waters encountered stretches of floating vegetation far from land, sometimes so extensive that they helped inspire stories about ships becoming trapped in weed-covered seas. The reality is different. Sargassum does not normally imprison ships. What it does create is a remarkable floating habitat in an otherwise open ocean. Small fish, crabs, shrimp, sea turtles, and other animals use these drifting patches as shelter and feeding grounds. That makes the Sargasso Sea an interesting contradiction in the middle of Bermuda Triangle mythology. A region often imagined as empty, dark, and hostile contains a vast floating ecosystem held together not by land but by currents. Southwest of Bermuda, the ocean eventually reaches Puerto Rico, and here the underwater landscape becomes more extreme. Just north of the island lies the Puerto Rico Trench, the deepest part of the Atlantic Ocean. Its deepest measured areas descend more than 8 kilometers below sea level. At those depths, there is no sunlight. The pressure is hundreds of times greater than at the surface. A ship can cross above this landscape without anyone aboard seeing any sign of it. The trench exists because this is a tectonically active boundary where enormous pieces of Earth's crust interact. Puerto Rico and the surrounding islands occupy a complicated geological zone between the North American and Caribbean plates. Earthquakes occur here. Tsunamis have affected the region in the past. None of this provides a mysterious force capable of swallowing aircraft, but it reveals something far more useful. The supposedly simple triangle crosses several completely different environments. Near Florida, a powerful current is squeezed through a narrow strait. Across the Bahamas, shallow banks suddenly meet deep channels. Around Bermuda, an ancient volcanic rise reaches toward the surface. Farther east lies a sea without shores. Near Puerto Rico, the Atlantic falls into its deepest trench. And above all of it is weather. Warm tropical water supplies energy to thunderstorms and hurricanes. Cold fronts can move off North America into the western Atlantic. Winds oppose currents and change the shape of waves. Conditions that look manageable in one place can be very different 100 miles away. Before modern satellites allowed meteorologists to watch entire weather systems from space, sailors and pilots often worked with a much smaller picture of what was developing beyond the horizon. This does not make the Bermuda Triangle uniquely cursed. It makes it an ocean. And that difference is important. The popular image of the triangle encourages us to search for one strange property shared by everything inside it. One magnetic anomaly, one unusual weather effect, one hidden geological mechanism. But the real region is almost the opposite. It is enormous and varied. A disappearance near the Florida coast may have little in common with an accident hundreds of miles away near Bermuda. Two events placed inside the same triangle on a map can occur in different depths, different currents, different weather, and completely different navigational circumstances. There is another detail that is easy to forget when looking at the famous 3 points. The distances are huge. Miami to Bermuda is roughly 1,000 miles. Bermuda to Puerto Rico is also around 1,000. This is not a small, dangerous corner of ocean that sailors accidentally wander into. Depending on how its borders are drawn, the triangle covers an area comparable in scale to a large country, and enormous numbers of journeys have crossed it safely. That fact will become important when we eventually ask whether disappearances really happen here more often than elsewhere. For now, it gives us something more useful: scale. A missing ship somewhere inside a region this large presents an extraordinary search problem. A missing aircraft whose crew is uncertain about its own position presents an even greater one. Deep water can hide wreckage. Currents can move debris. Weather can interfere with searches. Reefs can destroy ships near islands, while thousands of meters of water can conceal them farther offshore. None of those things explains every Bermuda Triangle case. They should not be forced to, but they change the question. Instead of asking what mysterious force exists inside 3 lines drawn on a map, we can begin asking what actually happened to individual people traveling through a real and complicated ocean. And one of the most disturbing examples began before the Bermuda Triangle even had a name. In February 1918, a massive United States Navy ship arrived in Brazil to collect a cargo needed for the war effort. She was nearly 550 feet long, carried hundreds of people, and belonged to a class of vessels built to move enormous quantities of material across the sea. Her name was USS Cyclops. Weeks later, after leaving Barbados for the United States, she disappeared with 306 people aboard. No confirmed wreck has ever been found. In February 1918, USS Cyclops was far from the waters where she would eventually disappear. She had been sent south to Brazil during the final year of the First World War, when ships like her performed work that rarely became famous but kept entire fleets moving. Cyclops was a collier, originally built to carry coal. At more than 540 feet long, she was a huge industrial ship for her time, with broad cargo holds and the capacity to move thousands of tons across the Atlantic. She had spent years supplying American warships, first in the Atlantic and Caribbean, and later as part of the enormous transport effort created by the war. By early 1918, however, the material inside her holds was not coal, it was manganese ore, a dense mineral important in steel production, and Cyclops was carrying roughly 11,000 tons of it back toward the United States. She left Brazilian waters in late February, bound for Baltimore. The original journey did not require a stop at Barbados, but Cyclops called there in early March. On board were 306 people, according to the Navy's historical accounting, including her crew and passengers traveling north. Among them was Alfred Louis Moreau Gottschalk, the United States Consul General at Rio de Janeiro. Cyclops was not an empty freighter disappearing unnoticed on some forgotten route. She was a United States Navy vessel traveling during wartime, carrying hundreds of people and an important cargo. When she departed Barbados on March 4, there was every reason to expect that she would eventually appear in Baltimore. She never did. There was no final message describing a storm, no report of flooding, no warning that the ship was breaking apart, no confirmed distress call giving rescuers a position to search. Somewhere after leaving Barbados, a vessel more than 500 feet long and everyone aboard simply disappeared from the known record. Days passed. Cyclops failed to arrive. Searches began. Ships looked for wreckage or survivors. Nothing conclusively belonging to her was found. More than a century later, there is still no confirmed wreck of USS Cyclops. To understand why this was so disturbing in 1918, it helps to remember what kind of year it was. The United States was at war with Germany. German submarines had already demonstrated how quickly large ships could be destroyed in the Atlantic. A missing Navy vessel naturally raised the possibility of enemy action. Perhaps Cyclops had been torpedoed. Perhaps a German raider had encountered her. If so, the absence of a distress call would not necessarily have been surprising. A ship could be hit suddenly, especially if an attack caused catastrophic damage, but there was a problem with that explanation. British intelligence had become remarkably successful at reading German naval communications and found no evidence connecting German forces with the disappearance. After the war, German records were examined as well. They provided no indication that a U-boat or raider had sunk Cyclops. The Germans apparently knew no more about her fate than the Americans did. One of the most obvious explanations had effectively disappeared with the ship. That left investigators with something much harder: the ship itself. Cyclops had not been in perfect condition. Her machinery had reportedly caused concern, and her unusual cargo introduced another question. Coal and manganese ore might both be carried in the hold of a large transport ship, but they do not behave in the same way. Ore is much denser. A large amount of weight can therefore be concentrated into a smaller volume, placing different stresses on the hull. A vessel designed primarily as a collier could be carrying enormous weight while its holds looked nowhere near as full as they would with coal. At sea, weight is only part of the problem. A long steel hull is constantly being bent by waves. Picture a ship passing over a large swell. For a moment, the bow and stern may be supported while the center experiences a different load. A little later, the center may be supported while the ends are placed under different stress. Ships are engineered for this movement, but structural weakness, heavy cargo, and rough conditions can combine in dangerous ways. If Cyclops suffered a major structural failure, it might have happened quickly enough to explain why no useful distress message was transmitted. There were other theories. Some suggested that the cargo shifted and caused the vessel to capsize. Others considered mechanical failure, severe weather, mutiny, or sabotage. Over the decades, as Cyclops became attached to the Bermuda Triangle story, the explanations became far more imaginative. Strange forces, methane gas, and eventually paranormal ideas were added to the list. But one of the most interesting clues did not come from anything mysterious around Cyclops. It came from two ships that looked almost exactly like her. Cyclops had 3 sister ships. One of them, Jupiter, followed a completely different path through history. She was eventually converted into USS Langley, the first aircraft carrier of the United States Navy. The other 2 were Proteus and Nereus. Both had been built as colliers. Both survived their Navy careers and were later sold into commercial service. And more than 2 decades after Cyclops disappeared, both of them vanished as well. In 1941, Proteus was carrying bauxite ore when she disappeared with her crew. Nereus was also carrying bauxite when she vanished later that year. Neither wreck has provided a clear explanation comparable to a recovered accident site, and the Navy's historical analysis notes an unsettling similarity. Cyclops, Proteus, and Nereus were all ships designed as colliers, yet each was lost while transporting dense metal ore rather than the coal they had originally been built to carry. There is no evidence that German submarines were responsible for the later losses either. 3 closely related ships, 3 heavy ore cargoes, 3 disappearances. That does not prove exactly what happened to any of them. It does, however, give us something far more useful than a paranormal theory, a pattern with a physical reason worth investigating. One explanation considered by Navy historians is that the design of these ships, combined with dense ore cargoes and structural weakness, made them vulnerable under the wrong conditions. Another theory, associated with Admiral George van Deurs, suggested that years of carrying coal could have contributed to corrosion of structural supports. Add heavy ore and a difficult sea, and the loads acting on an already weakened hull might become catastrophic. The Naval History and Heritage Command describes structural failure as the most likely explanation for Cyclops, while still acknowledging the basic problem that prevents the case from being closed. Without the wreck, the exact sequence cannot be known, and that difference is important. There is a temptation with mysteries like Cyclops to choose between 2 extremes. Either something inexplicable happened, or the mystery has been solved, but history often leaves us somewhere in between. There may be a strong explanation without enough evidence to prove it. We can know what a ship was carrying, we can study its design, We can examine the fate of sister ships. We can eliminate enemy action with reasonable confidence. We can identify mechanisms capable of sinking a vessel. What we cannot do is descend to a confirmed wreck, inspect the hull and reconstruct the final minutes. Those final minutes are what the Atlantic kept. Perhaps Cyclops encountered heavy seas and her structure failed. Perhaps the cargo shifted. Perhaps several problems occurred together. A mechanical difficulty could have reduced her ability to meet the waves correctly. Structural weakness could then have become more important. A heavily loaded ship does not need one spectacular cause if several ordinary problems arrive at the same time. Whatever happened, it seems to have happened with little or no warning reaching anyone on land. 306 people disappeared with the ship, making the loss the largest in US naval history, not directly involving combat. And yet Cyclops would eventually become something else. Decades after she vanished, writers drawing the boundaries of a mysterious region in the Western Atlantic could look backward and place her inside it. Suddenly, a wartime naval disappearance from 1918 became one of the earliest great mysteries of the Bermuda Triangle, even though nobody aboard Cyclops had ever heard that name. This is how the legend begins to take shape, not with a supernatural event, but with an unanswered one. For nearly 3 decades after Cyclops disappeared, there was still no famous triangle connecting her loss to anything larger. Then, on December 5, 1945, 5 American military aircraft took off from Fort Lauderdale on what should have been a routine training flight. Their disappearance would be different. Cyclops had left almost nothing behind except questions. This time, some of the men would still be speaking over the radio as the situation began to unravel. 27 years after Cyclops vanished, the mystery returned in a very different form. This time, there would be no enormous ship quietly failing to arrive at port. There would be 5 aircraft in the sky, men speaking to one another over the radio, a naval air station listening from Florida, and several hours in which a routine training mission slowly became something nobody on the ground could understand. On the afternoon of December 5, 1945, 5 TBM Avenger torpedo bombers prepared to leave Naval Air Station Fort Lauderdale. The Second World War had ended only months earlier, and the Avenger was anything but an experimental aircraft. It had been used extensively throughout the war, a large, tough carrier-based bomber designed to carry torpedoes and bombs over long distances. The men flying that afternoon were not heading into combat. Their assignment was Navigation Problem Number 1, a standard training exercise intended to give crews experience navigating over water. The plan was straightforward. They would fly east from Florida, conduct practice bombing at Hens and Chickens Shoals in the Bahamas, continue farther east, turn north, cross Grand Bahama, and then turn southwest for the flight back to Fort Lauderdale. If everything went as planned, the entire exercise would cover roughly 300 miles, and the aircraft would be home before evening. At 2:10 in the afternoon, the 5 Avengers climbed away from Fort Lauderdale and headed east. There were 14 men aboard. Leading them was Lieutenant Charles Carroll Taylor, an experienced naval aviator who had accumulated about 2,500 flying hours and served combat tours in the Pacific. Taylor was the instructor for the mission. The other pilots were students, although these were not beginners learning how to keep an aircraft in the air. They were receiving advanced training in the kind of navigation that military aviators needed when flying beyond sight of land. For the first part of the exercise, there was little reason for anyone to remember Flight 19. The aircraft reached the bombing area and completed their practice runs. Bombs were dropped without incident. Somewhere after that, as the formation continued along its planned route, the story changed. Around 3:40 in the afternoon, another instructor flying near Fort Lauderdale, Lieutenant Robert Cox, heard radio traffic that caught his attention. Someone appeared to be having trouble. A voice was repeatedly asking another pilot for a compass reading. Then came a message that revealed something more serious. The flight did not know where it was. Cox eventually established contact with Taylor and asked what was wrong. Taylor reported that both of his compasses were malfunctioning and that he was trying to find Fort Lauderdale. More importantly, he believed he was over the Florida Keys. He could see islands beneath him, but he was uncertain where along the Keys he might be. That one belief may have shaped almost everything that followed. If Taylor really had been over the Florida Keys, the solution was simple. Florida lay to the north. Cox tried to give him instructions that would bring him back toward Fort Lauderdale, but there was another possibility. Flight 19 may not have been over the Keys at all. The islands Taylor was seeing could have been the northern Bahamas, close to where the training route was supposed to take the formation. If that was true, then Taylor's mental map of his position had become displaced by hundreds of miles. And once that happens over open water, even a sensible decision can make the situation worse. A compass tells you which direction you are traveling. It does not tell you where you are. If you believe you are south of Florida, when you are actually east of it, a heading chosen to reach land can carry you farther into the Atlantic. The other pilots were not silent. Fragmentary radio transmissions indicate disagreement within the formation. Some apparently believed that flying west would take them home. At one point, a pilot could be heard suggesting that if they simply flew west, they would reach the coast. But Taylor was responsible for the flight, and from his understanding of their position, west did not necessarily make sense. This is one of the details that later retellings often flatten into a story about 5 aircraft suddenly losing all sense of direction. The real event was more human and more unsettling. The men were trying to solve a navigation problem while working from conflicting ideas about where they were. On land, help was trying to reach them, but radio communication was imperfect. Different stations could hear different parts of the conversation. Signals faded and returned. Attempts were made to obtain a radio bearing on the formation. Flight 19 was also encouraged to switch to an emergency frequency that might have improved communication, but Taylor was reluctant to change frequencies because he feared losing contact with the other aircraft. As the afternoon continued, the problem that had begun as uncertainty over position became a race against things that could not be negotiated with: daylight, weather, and fuel. The sun was moving toward the horizon. Conditions over parts of the Atlantic were deteriorating. The sea below was becoming rough, and every minute spent flying in the wrong direction consumed fuel that could never be recovered. Taylor changed headings more than once as he tried to determine where the formation was. At various points, transmissions suggested that the flight was moving north or northeast. Ground stations were gradually forming a better idea of where the aircraft might be, but knowing approximately where a lost formation was and successfully communicating that information to the men inside it were different problems. By early evening, the voices had weakened with distance. The aircraft were still somewhere over the water. One of the final messages attributed to Taylor ordered the planes to stay close together and prepare for the possibility of ditching when fuel became critically low. By then, darkness was approaching, and the Atlantic below was in poor condition. A British tanker in the area later reported tremendous seas and strong winds. An Avenger could be deliberately put down on water, but ditching a heavy aircraft into rough seas at night was extremely dangerous. Even surviving the impact would only begin another problem. The men would then be in open water in worsening weather, potentially far from the area searchers initially expected them to be. Eventually, the transmissions stopped. 5 Avengers and 14 men were somewhere beyond Florida, but nobody knew exactly where. Search aircraft were already being sent out. Among them were 2 Martin PBM-5 Mariners at Naval Air Station Banana River, farther north along Florida's coast. The PBM was a large flying boat designed for long patrols over the ocean. It could remain airborne for many hours and was well suited to search work. One of the aircraft, designated Training 49, carried 13 men. It took off shortly after 7:20 that evening, with enough fuel for a long mission. Minutes later, it made a routine radio transmission. Then it too disappeared. This second loss is one of the reasons Flight 19 became almost irresistible to later mystery writers. 5 military aircraft vanished together. A 6th aircraft is sent to search for them and also vanishes. Taken without context, it sounds as though whatever had taken Flight 19 had claimed its rescuers as well. But the evidence surrounding Training 49 points toward a very different event. A ship in the area reported seeing an explosion in the sky and later passed through an oil slick. Radar also tracked the Mariner before contact was lost. The PBM had an uncomfortable reputation among crews because gasoline vapor could accumulate inside the aircraft, creating a serious fire risk. Its nickname, according to Navy historical accounts, was the flying gas tank. The exact cause of Training 49's destruction was never established, but an in-flight fire or fuel vapor explosion is considered the most likely explanation. In other words, the sixth disappearance probably had nothing to do with whatever happened to the first five. The two events became connected because one aircraft was searching for the others. History would later connect them even more tightly. Through the night and into the following days, the search expanded enormously. Navy and Coast Guard aircraft flew over the Atlantic, the Bahamas, the Gulf of Mexico, and parts of Florida. Ships searched from the surface. Hundreds of aircraft and vessels would eventually become involved, covering an immense area. Yet there was no confirmed Avenger wreckage, no bodies and no life rafts that could be tied conclusively to Flight 19. The Atlantic had once again provided no final scene for investigators to examine. The Navy convened a board of investigation, and even there the story refused to settle into a simple answer. The evidence strongly suggested that Taylor became disoriented, probably mistook islands in the Bahamas for the Florida Keys, and led the flight away from the coast until fuel exhaustion forced the aircraft into the sea. The Navy's historical analysis still considers disorientation, navigation problems, worsening weather, and eventual fuel exhaustion the most likely chain of events. But the original investigation became controversial. Taylor's mother objected strongly to conclusions that appeared to place responsibility on her son when neither the aircraft nor the men had been recovered. She fought to clear his record, and the official finding was eventually changed so that the cause remained unknown. That wording would matter enormously in the decades ahead. Cause unknown is an honest conclusion when the physical evidence required for certainty is missing. But outside an accident investigation, those same two words can take on a completely different meaning. They can become an invitation. Flight 19 did not need invented radio messages, portals, or magnetic forces to be extraordinary. The documented story was already enough. 5 military aircraft left Florida on a routine exercise. Their leader became uncertain of his position. Other pilots appear to have questioned the route. Radio stations struggled to establish where they were. Darkness and bad weather approached. Fuel ran down, and eventually every voice disappeared. No confirmed wreck of any of the 5 Avengers has ever been recovered. Somewhere beneath the Atlantic may still lie the evidence that could tell us exactly how their final minutes unfolded. But by the time anyone began seriously searching for it, the possible area was enormous. And in the years that followed, Flight 19 stopped being only an aviation accident. Writers repeated the story. Details changed. Strange quotations appeared in versions that did not match the strongest historical record. The idea that the ocean itself had looked unusual became more dramatic. The failure to recover wreckage became evidence of something beyond an ordinary crash. Eventually, the 5 Avengers became the defining disappearance of a place that still did not officially exist. And Flight 19 would not stand alone for long. Other aircraft would fail to arrive. Ships would disappear between ports. Some cases would have evidence pointing toward ordinary causes. Others would remain genuinely difficult to explain. But once Flight 19 had given the emerging legend its most powerful story, separate tragedies scattered across the western Atlantic could begin to look like pieces of the same mystery. Once Flight 19 entered the public imagination, later disappearances no longer arrived as isolated events. They began to accumulate. A missing aircraft could now be compared with another missing aircraft. A ship that failed to reach port could be placed beside Cyclops. Each new case seemed to make the others more significant, and during the years after the Second World War, the Western Atlantic provided several stories that would eventually become permanent parts of the Bermuda Triangle legend. One of the most important began in January 1948, when a British South American Airways passenger aircraft named Star Tiger was crossing the Atlantic toward Bermuda. Star Tiger was an Avro Tudor 4, a 4-engine British airliner carrying 25 passengers and 6 crew. Its journey had begun much farther east, with Bermuda as the next destination after a stop at Santa Maria in the Azores. The flight was already operating under difficult circumstances. Strong winds were expected along the route, and the aircraft was flying unusually low for much of the journey, at around 2,000 feet, partly because of the weather and winds. Flying low over the Atlantic gave the crew very little height to work with if a serious mechanical problem developed. It also increased fuel consumption compared with the more efficient altitudes normally preferred for a long flight. Through the night, however, nothing suggested that a catastrophe was unfolding. Star Tiger remained in radio contact. Bermuda was waiting ahead. In the early hours of January 30th, the aircraft transmitted a routine position message. There was no distress call, no report that an engine had failed, no warning that the crew had become lost. Then Star Tiger simply stopped communicating. The aircraft never reached Bermuda. 31 people disappeared with it. A large search followed, but investigators never obtained the one thing that could have transformed the mystery into an accident investigation: the aircraft itself. Without wreckage, they could examine the route, weather, fuel, communications, and known condition of the aircraft, but they could not determine what physically happened in its final moments. The British investigation eventually reached an unusually frustrating conclusion. The available evidence was not enough to establish a cause. That did not mean there were no possible explanations. The low altitude left little time to react to trouble. Winds had complicated the journey. Navigation over a dark ocean depended on far less precise systems than those used today. Any sudden failure could have become serious very quickly, but none of those possibilities could be proved. Star Tiger became a mystery because the evidence stopped before the story did. Less than a year later, the same airline lost another Tudor aircraft over the Atlantic. On January 17, 1949, Star Aerial departed Bermuda for Kingston, Jamaica. The circumstances seemed different. The weather was generally good, and the aircraft was able to fly high rather than struggle along close to the sea. Radio messages from the crew were routine. Then contact ended. Star Aerial never arrived. 20 people were aboard. Again, searches found no wreckage capable of explaining the loss. 2 aircraft of the same airline, both disappearing over the Western Atlantic within 12 months, were almost guaranteed to become connected in later retellings. Yet even here, the similarity can hide the differences. Star Tiger had been fighting strong winds and flying low. Star Aerial disappeared under apparently better conditions. Investigators examined the Tudor aircraft, communications procedures, and possible failures, but the absence of physical evidence prevented a confident answer. British South American Airways itself would soon cease to exist as an independent airline, but the names Star Tiger and Star Aerial survived because mysteries are often remembered longer than ordinary flights that arrived safely. And in the same period, another aircraft disappeared on a route that ran directly between 2 of the Bermuda Triangle's future corners. On the night of December 27, 1948, a Douglas DC-3 prepared to leave San Juan, Puerto Rico, for Miami with 29 passengers and 3 crew. Unlike the clean version of the story that would later appear in mystery collections, there were already problems before the aircraft left the ground. Its batteries were badly discharged. The radio transmitter was not working properly. The crew was told that fully recharging the batteries would take hours, but the flight did not wait that long. Water was added to the batteries and the aircraft eventually departed, with the expectation that its generators would restore electrical power during flight. The arrangement was that the DC-3 would remain near San Juan until reliable radio contact had been established. Instead, it continued toward Miami. For most of the night, the aircraft apparently remained airborne without disaster. A message received later placed it at 8,500 feet and gave an estimated arrival in Miami shortly after 4 in the morning. Then, at 4:13, a transmission was intercepted, reporting the aircraft about 50 miles south of Miami. It sounded as though the long journey was almost over, but the DC-3 never appeared. Searchers looked across a huge area. Nothing conclusive was recovered. Once again, a passenger aircraft had seemingly reached the final part of its journey and then disappeared. But the official investigation found several details that changed the character of the story. The electrical system had been unreliable before departure. The batteries had not been properly recharged. The aircraft's transmitter had already been causing difficulty, and during the flight, the winds near Florida changed direction. If the crew did not receive updated weather information, that change could have pushed the aircraft dozens of miles away from where the pilots believed they were. The final reported position therefore becomes less reassuring than it first appears. Saying you are 50 miles south of Miami is useful only if that position is correct. If the aircraft was somewhere else, the crew could have continued searching for a coastline that was not where they expected it to be, while the remaining fuel continued to fall. The Civil Aeronautics Board could not determine the probable cause because the aircraft was never found. But the investigation did not describe a perfectly functioning DC-3 mysteriously erased from a clear sky. It described an aircraft that departed with known electrical problems, may have been affected by an unreceived change in wind information, and whose final position could not be independently confirmed. The difference between those two versions is small on paper and enormous in a documentary. One is a supernatural mystery. The other is an unresolved aviation accident, with several very real warning signs. Then came a ship, whose story would demonstrate the same problem even more clearly. In February 1963, Marine Sulphur Queen left Beaumont, Texas, bound for Norfolk, Virginia. She was a former oil tanker that had been converted to carry molten sulfur. Inside were more than 15,000 tons of sulfur, kept hot enough to remain liquid. 39 men were aboard. The vessel's final known radio communication came during the early hours of February 4. After that, she was not heard from again. When Marine Sulphur Queen failed to arrive, an enormous search began along her expected route through the Gulf of Mexico, the Straits of Florida, and toward the Atlantic. Aircraft flew hundreds of hours. Hundreds of thousands of square miles were searched. Eventually, debris belonging to the ship was recovered, including life jackets, life rings, name boards, and other items. The ship itself was never found. In Bermuda Triangle retellings, Marine Sulphur Queen often became another vessel that vanished mysteriously. The Coast Guard investigation tells a much darker and more complicated story. The ship had experienced repeated fires in insulation around its sulfur tanks. Sulfur leaks had occurred. Investigators learned that fires in some areas had become increasingly frequent in the months before the final voyage. The vessel had also suffered heavy weather damage in the past, and its conversion to carry molten sulfur created unusual structural and safety concerns. On the final voyage, rough conditions were reported along the route, with strong winds and significant seas. Investigators considered several possible ways the ship could have been lost. There could have been an explosion involving gases associated with the sulfur cargo. The hull could have suffered catastrophic structural failure. The ship might have broken apart. Other failures could have combined with the weather. The Coast Guard refused to pretend it knew which one happened because no surviving crew or wreck was available to provide the answer. But its investigation did not uncover a healthy ship traveling peacefully through calm water and suddenly disappearing. It uncovered a vessel with serious known hazards carrying a difficult cargo through rough conditions. That is a very different mystery, and it reveals something important about the Bermuda Triangle stories as they accumulated. The phrase, "cause unknown," began to do more work than it should. In an official investigation, cause unknown can mean there are several realistic explanations, but insufficient evidence to choose between them. In popular storytelling, cause unknown can slowly become no explanation exists. Those are not the same thing. There are cases, however, where even the surrounding circumstances provide remarkably little help. On December 22, 1967, a small cabin cruiser named Witchcraft left Miami with hotel owner Dan Burak and his friend, Father Patrick Horgan, aboard. They were not crossing the Atlantic. They were not heading for Bermuda or Puerto Rico. They had gone only a short distance offshore to view Miami's Christmas lights from the water. At around 9 that evening, Burak contacted the Coast Guard. He reportedly said the boat had struck something and needed assistance, but he did not describe an immediate life-threatening emergency. The location was close enough to Miami that help could reach the area quickly. Roughly 20 minutes later, rescuers were there. Witchcraft was not. Neither were Burak and Horgan. There was no obvious debris field showing where the boat had gone down. A search followed, but the vessel was never recovered. It is a wonderfully unsettling story because of its scale. A huge aircraft disappearing hundreds of miles offshore can be difficult to locate. A small boat apparently vanishing close to a brightly lit city feels harder to accept. But even witchcraft reminds us how little information is needed for a mystery to survive. We know the men went out, we know contact was made, we know rescuers could not find them. Everything important between those facts is missing. By the late 1960s, there were now enough cases to build almost any version of the Bermuda Triangle a writer wanted. Cyclops supplied the enormous missing ship. Flight 19 supplied the lost military aircraft. Star Tiger and Star Ariel supplied passenger airliners. The DC-3 supplied a disappearance near Miami. Marine Sulphur Queen supplied a modern commercial vessel. Witchcraft showed that even being close to shore did not guarantee an answer. But place the original investigation files beside the later legends, and a pattern begins to emerge that has nothing to do with magnetic fields or portals. Important details are often lost as the stories become shorter. Strong winds become clear skies. Known technical problems disappear. Dangerous cargo becomes ordinary cargo. Uncertain positions become precise last known locations. A search that recovered debris becomes a disappearance with absolutely no trace. Each removed detail makes the story easier to tell and harder to explain. The tragedies themselves remain real, so does the uncertainty. But perhaps we have been looking at the wrong part of these stories. Instead of staring only at the ship that failed to arrive or the aircraft that stopped transmitting, we need to look at the environment around them. The winds pushing an aircraft away from its expected course, the waves acting on a heavily loaded hull, the storms crossing the shipping lanes, and the moving water waiting beneath every one of them. Because the Atlantic does not need to make a vessel disappear in order to create a mystery. Sometimes, it only needs to make the final few minutes impossible to reconstruct. That means the weather surrounding these disappearances deserves more attention than it usually receives. On a modern map, the Western Atlantic can look almost too familiar to be dangerous. Florida sits on one side, the Bahamas just offshore, Puerto Rico farther south, Bermuda alone to the northeast. Commercial aircraft cross these waters every day. Cruise ships move through them in every season. But a map removes the one thing that matters most when you are actually out there. The ocean is constantly changing. A calm morning does not guarantee a calm afternoon, and a storm does not have to become a famous hurricane before it becomes dangerous. Sometimes the change begins with little more than a dark line on the horizon. Warm, humid air rises rapidly and builds into a thunderstorm. Winds strengthen. Visibility falls beneath heavy rain. The surface, smooth only minutes earlier, begins to break apart. For an aircraft flying before modern navigation systems, losing the horizon could make an already uncertain position much harder to understand. For a ship, the danger develops differently. Wind pushes against the water, and if it continues long enough across enough open sea, waves grow. Their size depends not only on how hard the wind blows, but on how long it blows and how much uninterrupted water lies beneath it. The Atlantic provides enormous distances over which that energy can build. A storm does not need to be directly overhead for its waves to reach you. Swells created far away can travel beyond the weather system that produced them, meaning a vessel can encounter a difficult sea, while the sky above gives only part of the story. In the region associated with the Bermuda Triangle, another force is already moving beneath those waves. The Gulf Stream carries warm water north through the Florida Straits and along the American coast. Most of the time, ships simply account for the current. Under the wrong weather conditions, however, the relationship between wind, waves, and moving water becomes much more serious. When strong winds blow against a powerful current, waves can become shorter, steeper, and more difficult for a vessel to handle. The National Hurricane Center specifically warns mariners about this effect in the Gulf Stream because tropical storm or hurricane-force winds opposing the current can quickly create extremely dangerous seas. Imagine a large ship meeting those waves head-on. The bow rises, hangs for a moment, then falls into the trough. The next wave arrives before the vessel has fully recovered. Every cycle places new forces through the hull. Cargo moves against its restraints. Water reaches parts of the deck that are normally dry. A ship that is properly loaded and structurally sound may endure it. A vessel already carrying a mechanical problem, structural weakness or unstable cargo may have far less room for error. Suddenly, the histories of Cyclops and Marine Sulphur Queen look different. Weather does not have to be the single cause of either disappearance. It can be the pressure that turns another weakness into a disaster. This is one reason the phrase, bad weather, can be misleading. It sounds like one simple condition. At sea, it can mean several dangers arriving together. Wind changes the waves. Waves act on the ship. Rain reduces visibility. Clouds remove visual references for pilots. Lightning and turbulence complicate flight. Currents push a vessel or floating debris away from where someone expects it to be. Even a local squall can matter if it arrives at exactly the wrong moment. Waterspouts add another dramatic feature to these tropical and subtropical waters. Some develop from thunderstorms and behave much like tornadoes over water. Others form in relatively fair weather beneath developing clouds and are usually weaker. They are real, sometimes dangerous, and visually extraordinary, but there is no need to turn them into an explanation for the Bermuda Triangle. The same rule applies to hurricanes. The Western Atlantic lies within one of the world's great hurricane regions. Warm ocean water provides energy and moisture to tropical cyclones, and the Bahamas, Florida, Puerto Rico, and waters around Bermuda have all experienced powerful storms. Mature hurricane can produce enormous waves and violent currents extending well below the surface. NOAA notes that hurricanes can generate waves around 60 feet high in extreme conditions, while the water movement beneath them can disturb the ocean far below what anyone sees from a ship. Yet saying hurricanes occur here does not solve the Bermuda Triangle. Many famous disappearances did not occur inside hurricanes. What matters is understanding the wider environment in which earlier sailors and pilots were operating, because their knowledge of that environment was nothing like ours. Today, before an airliner leaves Miami, its crew can examine satellite images showing weather across an enormous portion of the Atlantic. Meteorologists can follow tropical systems for days. Aircraft can fly directly into hurricanes to measure their winds and pressure. Weather radar reveals thunderstorms. Computer models estimate where storms may travel. Ships can receive updated forecasts far from land. Satellites can watch cloud systems develop over places where there may not be a single human observer. In 1918, when Cyclops disappeared, none of that existed. There were weather observations from ships and islands, pressure readings, forecasts built from limited information, and the experience of sailors watching the sky and sea around them. But there was no satellite above the Atlantic showing the entire system. Even by 1945, when Flight 19 disappeared, meteorology was still working without the continuous satellite view we now take for granted. Routine aircraft reconnaissance of tropical cyclones had only begun during the Second World War, and continuous weather satellite surveillance would not arrive until the mid-1960s. That difference is difficult to appreciate because modern weather maps make storms feel almost visible before they arrive. We see the spiral of a hurricane hundreds of miles across. We watch forecasts extend several days into the future. Earlier crews experienced weather much more locally. What was happening at their position might be known. What was developing far beyond the horizon could be much less certain. And even with perfect knowledge of the weather, the sea itself can still produce surprises. For centuries, sailors returned from storms with stories of individual waves far larger than the sea around them. Some described walls of water appearing with little warning. Ships sometimes arrived in port with damage high above the normal waterline. Others never arrived at all. For a long time, reports of enormous isolated waves were difficult to separate from exaggeration. Oceanographers understood that very large waves were possible, But the idea of a single wave dramatically exceeding its neighbors was hard to confirm, because the open ocean is an enormous place, and instruments were rarely positioned exactly where such an event occurred. Then better measurements began changing the picture. What sailors had described as freak waves became a real subject of ocean science. Today they are usually called rogue waves. The definition is less mysterious than the name. A rogue wave is an unusually large wave compared with the surrounding sea, commonly defined as more than twice the significant wave height, which is a measure based on the larger waves present around it. They are not tidal waves, and they do not require an earthquake or some unknown force beneath the ocean. They can emerge from the complicated way waves interact with one another. When different wave systems overlap, their energy can briefly combine. Currents can also change wave behavior, and researchers continue studying exactly how extreme waves form and how often ships encounter them. The important discovery was not that the Atlantic contained supernatural walls of water. It was that a phenomenon once treated with skepticism because it was difficult to observe directly was physically real. That matters to our investigation, but it also creates a trap. Once rogue waves became accepted science, they became an attractive answer for almost any unexplained shipwreck. Cyclops vanished? Perhaps a rogue wave. Marine Sulphur Queen disappeared? Perhaps another. An unknown vessel goes down in rough seas. Add the same explanation again. But the existence of a mechanism is not evidence that it caused a particular accident. Unless a wave was observed, measured, reconstructed from weather and sea conditions, or supported by wreck evidence, assigning one to a ship lost decades ago remains a possibility, not a solution. This distinction will become important again and again. The Bermuda Triangle contains many explanations that are physically possible. The harder question is whether there is evidence connecting them to a specific disappearance. Rogue waves are real, hurricanes are real, waterspouts are real, powerful currents are real. None of that means one of them can simply be placed into every blank space in the historical record. What science can do is tell us what the environment is capable of. It can show why a sea described as merely rough in an old report may have been far more dangerous to a particular vessel than those two words suggest. It can explain how a current running against the wind changes waves, why a heavily loaded ship experiences stress as it moves over them, or why a pilot already uncertain of his location becomes more vulnerable when cloud and rain remove the horizon. The interesting part is rarely one dramatic force. It is the combination. A navigation error that would be recoverable in clear weather becomes harder in a squall. An engine problem that would be manageable near land becomes serious over hundreds of miles of ocean. A structurally weakened ship may survive ordinary seas for years and fail on the voyage when the waves finally place the wrong load on the wrong part of the hull. A storm does not have to make something vanish. It only has to remove the margin that was keeping everything else under control. And then, if the vessel goes down, the weather continues working. Waves break wreckage apart. Wind pushes floating objects across the surface. The Gulf Stream carries them away. Search aircraft may be unable to see through cloud or rough water. Rescue ships themselves have to operate safely in the same conditions that may have caused the accident. Hours pass, and the location where evidence should be found begins to move. This is the part of the Bermuda Triangle story that is easiest to overlook. Sinking is one mystery. Disappearing is another. A ship can be destroyed by perfectly understandable forces and still leave investigators with almost nothing to examine. An aircraft can enter the Atlantic in a known general area and become extraordinarily difficult to locate. The famous phrase is always the same: nothing was found. But before treating that absence as evidence of something impossible, we need to understand what happens to wreckage, fuel, life jackets and bodies once they enter a deep ocean that never stops moving. But once something enters the Atlantic, the accident itself may be only the beginning of its disappearance. Imagine a search aircraft arriving over the ocean several hours after a distress call. The crew has coordinates for the vessel's last reported position, so they begin there. Below them is an enormous field of moving water. There are no roads, buildings, or landmarks to show where the accident happened. The surface looks almost identical in every direction. Somewhere beneath it may be an aircraft, a ship, a life raft, or hundreds of pieces of wreckage. The search crew is not really looking for the missing vessel anymore. They are looking for signs of it. An oil slick, a bright life jacket, floating luggage, a piece of wing, an overturned raft, anything that breaks the pattern of the sea. And while they are searching, the search area itself is changing. This is where the Gulf Stream becomes important again. Between Florida and the Bahamas, enormous volumes of warm water are moving north. Something light enough to remain at the surface can be carried with that water while wind pushes it in another direction. A life jacket will not necessarily drift exactly like a piece of aircraft skin. A partly submerged object behaves differently from something floating high above the surface. A body, raft, and fuel slick can begin near one another and gradually separate. Search and rescue specialists call this drift, and today they use computer models that combine currents, winds, and the behavior of different objects to estimate where survivors or debris may move. Modern Coast Guard search planning can even account for the fact that different objects respond differently to wind. But in the years when many famous Bermuda Triangle disappearances occurred, rescuers had nothing approaching today's ability to model that movement. They worked from the best observations available, reports from ships and aircraft, estimated currents, weather information, and the missing vessel's last known position. And that last part can create the biggest problem of all. A last known position is only useful if it really was the vessel's position. Think back to the missing DC-3 approaching Miami in 1948. Its crew transmitted an estimate, placing the aircraft about 50 miles south of the city. But investigators later considered the possibility that changing winds had pushed it away from its expected track. If the pilots were wrong about where they were, searchers beginning from the reported position could be looking in exactly the wrong piece of ocean. Flight 19 created an even greater problem. Its crews themselves were uncertain about their location. Taylor believed at one stage that he was over the Florida Keys. Other evidence suggested the formation may have been over the Bahamas. Later radio bearings gave searchers clues, but not the precise final coordinates that modern GPS might provide. Now imagine 5 aircraft continuing to fly for hours while rescuers try to work out which direction they have gone. Every minute adds distance. If an aircraft is traveling at 100 miles an hour and its heading is uncertain, even a relatively small error in estimating its route can create a huge area of possible positions by the time its fuel runs out. The search is no longer for one point. It becomes a widening fan of ocean. Darkness arrives. Weather reduces visibility. The aircraft finally ditch somewhere inside that area, and the current immediately begins moving whatever remains on the surface. This is one reason searching the sea is fundamentally different from searching land. If an aircraft crashes into a mountain, the mountain stays where it was. Even years later, investigators can return to the location. The Atlantic does not preserve an accident scene at the surface. It takes it apart. Heavy components begin sinking almost immediately. Engines, landing gear, and dense machinery may descend rapidly. Lighter materials can remain afloat. Fuel spreads into a thin slick. Personal belongings can drift away. Waves break structures apart further. If an aircraft hits the water at speed, much of the breakup may happen during impact itself. Water seems soft when we swim through it, but at aircraft speed, it can impose devastating forces. A machine can enter the sea as one object and become a scattered debris field in seconds. Ships disappear differently. A large vessel may remain intact long enough to sink as one structure, or it may break apart at the surface or during the descent. Cargo can spill from damaged holds. Deck equipment separates. Air trapped inside compartments escapes. Pieces with enough buoyancy rise or remain afloat while the main wreck continues downward. The deeper the water, the farther that descent becomes. And much of the Atlantic associated with the Bermuda Triangle is very deep. Once a wreck reaches the bottom, a second kind of disappearance begins. Sunlight is gone. Human eyes cannot simply look down from a ship and see what lies below. Sediment can settle across wreckage, metal corrodes, marine organisms colonize exposed surfaces, wood and other materials deteriorate. Strong bottom currents can move smaller pieces. Over decades, a wreck that began as a recognizable machine becomes part of the seafloor. This does not mean wrecks vanish completely. In fact, deep water can sometimes preserve surprising amounts of a vessel because cold, dark conditions slow certain forms of decay. But finding that wreck is another matter entirely. Consider the scale involved. A large aircraft may have a wingspan of only a few dozen feet. A ship hundreds of feet long sounds enormous until it is placed on an ocean floor covering millions of square miles. If the final position is uncertain by 50 miles, even a large wreck becomes a tiny target inside a search box larger than many cities. If uncertainty extends to hundreds of miles, the problem becomes almost absurd. Before modern sonar, searchers were especially limited. Aircraft could scan the surface. Ships could look for floating debris. Divers could investigate shallow sites. But if a vessel sank into thousands of feet of water at an unknown location, there was often no practical way to search every part of the bottom. This helps explain why "nothing was found" appears so often in historical accounts. In many cases, searchers were not proving that no wreck existed. They were proving that they could not find one with the information and technology available to them. Modern ocean exploration has changed what is possible. A research ship can map the seabed with multi-beam sonar, sending sound toward the bottom and measuring the echoes that return. Side-scan sonar can reveal objects and shapes lying across the seafloor. Remotely operated vehicles can descend far beyond safe diving depths while pilots control them from a ship above. Cameras can inspect wreckage in complete darkness. Autonomous underwater vehicles can survey large areas without a person physically guiding every movement. These technologies have allowed researchers to locate ships that were lost for generations. But even the best sonar cannot tell you where to search if your starting information is wrong. This is why finding famous lost aircraft and ships can still take decades. Search vessels must first choose an area. They then travel back and forth across it in carefully spaced lines, gradually building a picture of the bottom. In shallow water, that may be manageable. In deep water, over an enormous uncertain area, it can require weeks, months, or years of work. Every strange shape must then be investigated. The Atlantic floor is not a clean, empty surface waiting for one obvious aircraft. There are rocks, ridges, sediment features, shipwrecks from other disasters, cables, and countless natural shapes that can produce interesting sonar returns. Flight 19 demonstrates the problem perfectly. Over the decades, wrecked Avengers have been discovered in Florida and Bahamian waters. Each discovery can create excitement because the aircraft type matches. But Avengers were common military aircraft, and many were lost in training accidents during and after the war. Finding an Avenger does not mean finding Flight 19. Identifying one requires serial numbers, markings, structural details, or other evidence connecting the wreck to the missing formation. In 1991, 5 Avengers were famously discovered underwater near Florida, creating headlines that Flight 19 might finally have been located. Investigation showed that they were not the missing aircraft. The coincidence sounded extraordinary until one remembers how much military training occurred around Florida and how many aircraft were lost there. The seafloor contains its own history, and not every wreck belongs to the mystery we want it to solve. USS Cyclops presents an even larger challenge. A ship more than 500 feet long should seem impossible to lose forever. Yet if nobody knows where she sank, the possible search area extends across a vast section of Atlantic. There was no distress call narrowing the location. No confirmed debris field marked the site. No survivor described the final hours. Cyclops could be resting somewhere in deep water, recognizable enough that modern sonar might identify her if a survey passed directly overhead, while still remaining effectively invisible because nobody knows which stretch of seabed deserves that survey. This is perhaps the least mysterious and most frustrating explanation for many lost wrecks. The ocean is simply much larger than the object we are trying to find. There is also a human tendency to imagine a search as more complete than it really can be. When historical records say aircraft and ships searched hundreds of thousands of square miles, it sounds as though every part of that ocean was examined closely. But searching from the air is not the same as draining the sea. A crew flying several hundred feet or several thousand feet above rough water has only seconds to notice an object before it passes behind them. Whitecaps can resemble debris. Debris can disappear between waves. Rain blocks visibility. Darkness ends visual searching almost completely. A life raft that seems brightly colored from a few meters away becomes a tiny point against an entire Atlantic. Even modern search operations can struggle to locate objects when the initial position is uncertain. The disappearance of Malaysia Airlines Flight 370 in 2014 demonstrated this on a scale almost impossible to ignore. Despite satellites, modern radar analysis, advanced ocean modeling, ships, aircraft, sonar, and enormous international resources, the main wreckage has still not been located as of 2026. Pieces confirmed or strongly linked to the aircraft later washed ashore across the Western Indian Ocean, some thousands of kilometers from the suspected crash region. The comparison does not make Flight 19 equivalent to MH370, but it shows something important. Even in the 21st century, an aircraft can disappear into a vast ocean and remain extraordinarily difficult to find when its final position is unknown. Now return to 1945. Remove GPS. Remove satellites capable of tracking the aircraft. Remove modern drift models. Remove multi-beam seabed maps. Put 5 Avengers somewhere over the Western Atlantic at dusk, with worsening weather and disagreement over position. Then ask searchers to find the exact place where they eventually entered the water. The absence of wreckage begins to look very different. Vanished without a trace is one of the most powerful phrases ever attached to the Bermuda Triangle because it sounds like a description of what happened. Often, it is really a description of what happened afterward. Something went wrong. The vessel entered the ocean. The evidence separated. Some sank, some drifted. Searchers arrived with imperfect coordinates. Hours became days. The floating evidence moved farther away, while the wreck remained somewhere beneath thousands of feet of water. No wreckage found does not mean no wreckage existed. It means nobody successfully connected the enormous moving surface of the ocean with the tiny place where the evidence was waiting. But that can only explain why Flight 19 has been so difficult to recover. It does not explain the stranger problem that came before the crash, how 5 military aircraft, beginning a familiar training exercise within reach of the Florida coast, could become uncertain enough about their own position to fly until their fuel was nearly gone. For that, we have to return to something that appears in almost every version of the Bermuda Triangle story, usually in a far more mysterious form than it deserves: the compass. The compass became one of the most famous objects in the Bermuda Triangle story because it offers such a simple image. A pilot looks down, and the instrument that should point north suddenly cannot be trusted. But real navigation is more complicated than a compass behaving correctly or incorrectly. A compass can work perfectly while the person reading it is completely lost. To understand how that can happen, forget Flight 19 for a moment and imagine flying over Florida on a clear afternoon. Below you are roads, cities, rivers, and coastlines. If you become uncertain about your position, the landscape can help you recover it. Fly east, and eventually you reach the Atlantic. Fly west across southern Florida, and eventually you reach the Gulf of Mexico. Even without modern GPS, recognizable features can tell you where you are. Now continue east until Florida disappears behind you. The view changes completely. Water fills almost everything beneath the aircraft. Small islands may appear, but from several thousand feet, one low Bahamian island can look remarkably similar to another. There are no road signs in the sky. Knowing which way north lies is no longer the same thing as knowing where you are. That difference sits at the heart of Flight 19. A magnetic compass does something very useful, but very limited. It gives direction by responding to Earth's magnetic field. The The complication is that the north, shown at the top of a normal map, is based on the geographic North Pole, while a magnetic compass aligns with magnetic north. Those 2 points are not in the same place. The angle between true north and magnetic north changes depending on where you are, and navigators call that difference magnetic variation or magnetic declination. Pilots did not discover this problem in the Bermuda Triangle. It is a normal feature of navigation all over the planet. Aviation charts show the correction that should be applied in different regions, and navigators account for it when planning a route. There are places where magnetic north and true north happen to line up, forming what is known as an agonic line. But that line is not fixed forever. Earth's magnetic field changes slowly, so the location of zero variation moves with time. The often repeated claim that the Bermuda Triangle is one of only a few places where a compass points to true north, therefore takes an ordinary and changing feature of Earth's magnetic field and turns it into something unique. It is not evidence of a mysterious magnetic zone. There is another source of error even closer to the pilot. Aircraft contain metal, electrical wiring and equipment capable of producing small magnetic effects of their own. These can disturb the compass slightly, producing what aviators call deviation. The correction can be measured and recorded. A magnetic compass can also behave imperfectly while an aircraft is turning, accelerating, or flying in certain attitudes. Pilots are trained to understand these limitations. None requires an unknown force outside the aircraft. But even after all those corrections have been made, the navigator still faces a much larger problem. Direction is not position. Before GPS, one of the basic ways to navigate across open water was dead reckoning. The idea is simple. Begin from a known location. Fly a known direction at an estimated speed for a measured amount of time. Correct for the wind, and you can estimate where you should be. If an aircraft travels east at 120 miles an hour for 1 hour, its crew can estimate that it has moved roughly 120 miles east. In reality, the calculation becomes more complicated because the air itself is moving. A strong wind from one side can push an aircraft away from its intended path without anything appearing wrong from the cockpit. The pilot can hold exactly the planned compass heading and still arrive somewhere other than the planned destination. Navigators therefore estimate wind direction and speed and correct for that drift. The system works remarkably well when the information going into it is good. The danger comes when a small uncertainty enters early and remains unnoticed. Suppose your estimated position is wrong by 20 miles. You continue flying and make the next calculation from that incorrect point. Now the new position is built on the first error. Add an unexpected wind, an incorrect time estimate, or a mistaken island identification, and the gap between where you are and where you think you are can continue growing. The aircraft itself may be functioning normally throughout. This is what makes the final hours of Flight 19 so compelling. The official Navy history records that Taylor reported problems with his compasses, so genuine instrument trouble cannot simply be dismissed. But the evidence also suggests something more important was happening. He appears to have formed the wrong picture of where the formation was. Taylor believed he was seeing the Florida Keys. The training route, however, had taken Flight 19 east from Fort Lauderdale toward the Bahamas. Other instructors on the ground quickly realized that if the mission had followed its planned first legs, there had not been enough time for the aircraft to be where Taylor thought they were. Lieutenant Robert Cox reached the same conclusion when he tried flying south from Fort Lauderdale to get closer to the formation. Instead of Flight 19's radio signals becoming stronger, they became weaker. The aircraft were apparently moving farther away. Now place yourself inside Taylor's cockpit. If the islands below really are the Florida Keys, then the Atlantic is on one side of you and the Gulf of Mexico on the other. Your solution depends on that geography. But if those islands are actually part of the Bahamas, the entire map inside your head is wrong. A heading that seems designed to find Florida can instead carry you farther over open water. This is why the other pilots could apparently disagree with their leader, while everyone involved was still acting logically from the information they believed. Ground stations wanted Flight 19 to head west. At one point, students were heard insisting that flying west would get them home. Taylor remained uncertain because west made less sense if his assumed location was correct. He also declined a request to change to the search and rescue radio frequency because he feared losing communication with the other aircraft. These decisions sound inexplicable only when we already know what Taylor did not know, that his understanding of the flight's location was probably wrong. That is how disorientation can become dangerous without anyone suddenly forgetting how to fly. One mistaken assumption changes the meaning of everything that follows. Islands become the wrong islands. A correct compass heading becomes the wrong route home. Advice from the ground conflicts with what the pilot believes he can see. The longer the aircraft continue, the harder it becomes to abandon the original assumption, because doing so means accepting that the formation may now be somewhere completely different. Meanwhile, fuel is being consumed and daylight is disappearing. Flight 19 also lacked the effortless position information that modern pilots have come to rely on. Today, satellite navigation can place an aircraft on a digital map with extraordinary accuracy. A crew crossing the Bahamas can know its position, ground speed and track almost continuously. In 1945, navigation depended much more heavily on compasses, clocks, charts, radio aids, calculations, visual observations, and the navigator's ability to combine them correctly. The Navy's reconstruction notes another troubling detail. Taylor may not have had a functioning watch available to him, and his aircraft apparently had no cockpit clock. Radio exchanges suggest he repeatedly asked the other crews how long they had been flying particular headings. Time was not a minor detail. In dead reckoning, time is part of position. If you do not know accurately how long you have traveled on a heading, estimating where that heading has taken you becomes much harder. None of this proves exactly what happened inside Taylor's cockpit. The aircraft have never been recovered, and the Navy itself acknowledges that the exact reason for his disorientation cannot now be known. But it gives us a far more believable sequence than 5 compasses simultaneously surrendering to a mysterious force. Taylor may have experienced compass trouble. He almost certainly became uncertain about position. He appears to have mistaken the geography beneath him. The formation then spent precious time flying, while that uncertainty remained unresolved. A worsening weather front approached. Fuel eventually became critical. The Navy's historical assessment is that the 5 Avengers most likely ditched in rough Atlantic water after running out of fuel. The compass mystery therefore changes when examined closely. The interesting question is no longer why North stopped existing inside the Bermuda Triangle. North never disappeared. The pilot's relationship to it did. A compass can tell a lost person exactly which direction he is traveling, while offering no answer to the question he needs most. Where am I? And once we understand that, one of the Triangle's most famous supernatural claims becomes a story about something much more familiar: how human beings make decisions when their instruments, surroundings, and expectations no longer agree. But the compass is only one proposed explanation. Over the decades, people have looked beneath the seabed, into the atmosphere, and even beyond conventional science, for something powerful enough to explain the disappearances. Some of those ideas sound absurd immediately, others sound surprisingly scientific, and one of the most persistent begins with something that really does exist beneath parts of the world's oceans: enormous quantities of methane trapped inside the seafloor. The idea is compelling because methane hydrates are not imaginary. Far below the surface in parts of the world's oceans, methane can become trapped inside structures of water ice when pressure is high and temperatures are low. They look almost like ordinary ice, yet contain gas. Disturb the conditions enough, and that methane can be released, which led to an intriguing question. Could a sudden eruption of gas rise through the ocean, fill the water with bubbles, and cause a ship to lose buoyancy? Laboratory experiments and physical models have shown that large concentrations of rising gas can affect how an object behaves in water under particular conditions. From there, it is easy to see how the idea became attached to the Bermuda Triangle. A ship is traveling normally. An enormous release occurs beneath it. The surrounding water fills with gas. the vessel loses support and sinks so rapidly that there is no time for a distress call. It sounds scientific because the ingredients are scientific. Methane hydrates exist. Gas can escape from the seabed. Bubbles can affect buoyancy. But a possible mechanism is not the same thing as evidence for an event. To explain Cyclops, marine sulfur queen, or another famous disappearance, there would need to be evidence that a release large enough to endanger the vessel actually occurred at the right place and time. That evidence has never been established. There is also no accepted scientific evidence that methane eruptions are unusually responsible for disappearances in the region commonly called the Bermuda Triangle. NOAA specifically notes that large methane hydrate fields exist in many parts of the world, and that there is no evidence linking methane releases to the famous Triangle incidents. The theory survives because it provides something the legend has always wanted: one hidden force capable of explaining everything. The problem is that the cases themselves refuse to cooperate. The same is true of rogue waves. Unlike many Bermuda Triangle theories, rogue waves have moved firmly from sailors' stories into measured science. Instruments have recorded individual waves dramatically larger than the surrounding sea, and researchers now study how currents, winds, and interacting wave systems can help create them. In the western North Atlantic, the Gulf Stream makes that research especially interesting because strong opposing winds and currents can produce dangerous sea states. A large unexpected wave could damage or overwhelm a vulnerable ship. But once again, there is a difference between saying a rogue wave could sink a ship and saying a rogue wave sank Cyclops. Without a surviving witness, measurement, or wreck showing damage consistent with that sequence, the theory remains possible rather than proven. If every missing vessel is assigned a rogue wave simply because rogue waves exist, we have replaced one unsupported explanation with another. Magnetic anomalies have an even longer history in the legend. Stories describe compasses behaving unpredictably, navigation instruments becoming useless, and aircraft losing direction after entering the triangle. Yet Earth's magnetic field is not perfectly uniform anywhere. Magnetic variation changes across the planet and changes slowly through time. Local magnetic disturbances can exist where geology influences measurements, and instruments themselves have limitations. None of that demonstrates a unique magnetic force covering the Florida, Bermuda, Puerto Rico region. NOAA states that there is no evidence the Bermuda Triangle contains unusual magnetic properties responsible for the disappearances associated with it. The famous claim about compasses pointing to true north in the triangle also confuses a normal navigational feature with something extraordinary. There are places where magnetic north and geographic north align, but those locations shift as Earth's magnetic field changes. The Bermuda Triangle does not own that phenomenon. Weather is different because we already know it has killed people here. Hurricanes cross the western Atlantic. Powerful thunderstorms can form quickly. Squalls reduce visibility. Winds can build steep seas, especially where they oppose strong currents. But weather becomes misleading when it is turned into another universal answer. Flight 19 was dealing with worsening conditions, yet weather alone does not explain why Taylor became uncertain of his position. Marine Sulfur Queen encountered difficult seas, but investigators also had concerns about the ship itself. Star Tiger faced strong winds and flew unusually low, while Star Ariel disappeared under apparently better conditions. The cases keep resisting a single cause because they involve different machines, different crews, different decades, and different circumstances. Theories become stranger when the investigation moves away from physics entirely. Atlantis became attached to the Bermuda Triangle, partly because the Bahamas provided a perfect setting for it. In 1968, pilots flying near North Bimini reported seeing an unusual formation beneath shallow water. Divers found a line of large, roughly rectangular limestone blocks extending across the seafloor. It became known as the Bimini Road. To anyone already interested in Atlantis, the appearance was irresistible. Here were stone-like blocks beneath clear Bahamian water, apparently arranged like an ancient road or wall. Inside the wider region, already becoming famous for unexplained disappearances, Some writers suggested that the formation could be part of a lost civilization, perhaps even the remains of Atlantis itself. Geologists studying the site reached a less spectacular but far better supported explanation. The blocks are beach rock, naturally cemented coastal sediment that can fracture along joints into surprisingly regular shapes. Similar formations occur elsewhere. Nature does not need to produce perfect circles or random piles to be natural. Rock can break along straight lines, creating structures that look designed when seen through clear water. Atlantis nevertheless became useful to Bermuda Triangle mythology because it offered a hidden source of power. Some versions imagined lost technology beneath the ocean, interfering with ships and aircraft. But there is no archaeological evidence connecting Bimini to Plato's Atlantis, and no evidence that the rocks generate forces capable of affecting navigation. By the 1970s and 1980s, the triangle had become flexible enough to absorb almost any mystery. One of the most unusual later claims involved what pilot Bruce Gernon called electronic fog. Gernon described a flight near the Bahamas in which his aircraft encountered an unusual cloud formation, experienced strange instrument effects, and appeared to cover a distance faster than expected. His story later became closely associated with Bermuda Triangle television programs and books, where the strange cloud was sometimes treated as evidence of a space-time distortion. The account is fascinating because it combines several things pilots genuinely experience: cloud, loss of visual references, changing winds, instrument interpretation, and uncertainty about position, with a conclusion that would require extraordinary evidence. No repeatable physical phenomenon called electronic fog has been established by atmospheric science as a Bermuda Triangle effect, and no measured space-time anomaly has been demonstrated there. That does not mean a witness is necessarily inventing what they remember. People can accurately report that they experienced something extraordinary while being wrong about what caused it. That distinction becomes even more important when we reach the theories of portals and extraterrestrial activity. Aliens became almost inevitable once the Bermuda Triangle entered the same popular culture that was fascinated by UFOs. If aircraft could disappear without wreckage and ships could vanish without distress calls, perhaps something had removed them. A portal offered an even cleaner solution. The missing vessel did not sink at all. It left our normal world. These ideas solve the hardest part of the mystery by making evidence unnecessary. No wreckage becomes proof that the vessel went somewhere else. No survivors become proof that nobody returned. But an explanation that turns missing evidence into evidence for itself cannot easily be tested. There is no verified physical evidence showing that extraterrestrial craft, dimensional portals, or distortions in time are responsible for disappearances in the Western Atlantic. Their importance is cultural, not scientific. They reveal how far the Bermuda Triangle had traveled from the original accident reports. Cyclops began as a missing Navy ship carrying heavy manganese ore. Flight 19 began as a navigation exercise in which the leader became uncertain about his location. Marine Sulphur Queen was a converted tanker with documented safety concerns. Over time, those separate histories were placed beneath the same collection of theories, as though one mechanism had to connect them. But perhaps that assumption has been the mistake all along. A ship can suffer structural failure. An aircraft can become lost. Another vessel can encounter severe weather. A different aircraft can experience mechanical trouble. The fact that all are later drawn inside the same shape does not mean they shared a cause. In fact, the search for one grand explanation may tell us more about the legend than it does about the Atlantic. Because if there is no single phenomenon connecting these events, then the most important question changes completely. Instead of asking what created the Bermuda Triangle, we have to ask who created it, and why so many unrelated disappearances eventually became one story. The strangest thing about the Bermuda Triangle may be that the legend arrived after many of its most famous mysteries had already happened. When Cyclops disappeared in 1918, there was no Bermuda Triangle for the newspapers to blame. When Flight 19 vanished in 1945, the pilots were not entering a region they had been warned to fear. Star Tiger, the missing DC-3, and other early cases were originally separate stories, investigated separately, involving different circumstances. The connection between them came later. One important step appeared in September 1950, when Associated Press journalist Edward Van Winkle Jones wrote about a series of unexplained losses between Florida and Bermuda. He mentioned Flight 19, Star Tiger, Star Ariel, and other incidents. There was still no famous triangle with 3 fixed corners, but the idea was beginning to form. Perhaps these disappearances belonged together. 2 years later, George X Sand pushed the story further in Fate magazine with an article titled "Sea Mystery at Our Back Door." Sand focused on several unexplained losses in the Western Atlantic and argued that something unusual appeared to be happening in a roughly triangular region. This was an important change. Individual accidents were becoming geography. Once the disappearances were placed on the same map, they began to look like a pattern. The name that would make that pattern famous arrived in 1964. Writer Vincent Gaddis published an article in Argosy magazine called "The Deadly Bermuda Triangle." Gaddis gathered several already familiar disappearances and placed them inside a triangular area stretching roughly between Florida, Bermuda, and Puerto Rico. He later included the idea in a book. The phrase was simple, visual, and almost impossible to forget. Western Atlantic disappearances sounds like a subject for an accident report. Bermuda Triangle sounds like a place. And once a mystery has a place, it can acquire a history. Events from decades earlier could now be pulled backward into it. Cyclops became a Bermuda Triangle disappearance, even though the concept had not existed when the ship sailed. Flight 19 became perhaps its defining case. Star Tiger and Star Ariel joined it. Marine Sulphur Queen could be added. Smaller boats, abandoned vessels, and other aviation accidents became part of the same growing archive. The borders were useful precisely because they were never completely fixed. If a compelling disappearance happened near an edge, the region could be drawn widely enough to include it. Different books eventually used different shapes and sizes. The triangle was becoming less like a geographical area and more like a way of organizing stories. Then, in 1974, Charles Berlitz transformed that collection of stories into a global phenomenon. His book, The Bermuda Triangle, became a bestseller and helped introduce millions of readers to a version of the region filled with missing aircraft, vanished ships, strange compass behavior, unexplained weather, and possibilities extending beyond conventional science. Berlitz was already a successful writer and came from the family associated with the famous language schools. But this book made his name inseparable from the mystery. The timing was perfect. The 1970s were fascinated by UFOs, ancient civilizations, psychic phenomena, and unexplained events. The Bermuda Triangle could contain all of them. It was modern enough to involve aircraft and radio communication, ancient enough to be connected with Atlantis, and remote enough that missing evidence could remain missing. Television made the story even stronger, because the triangle was naturally visual. Draw 3 lines across a map. Show an Avenger disappearing into cloud. Put a compass beside it. Show a ship on an empty sea. Ask what could possibly explain so many disappearances. The shape itself did much of the storytelling, but as the legend became cleaner, the accidents inside it often became cleaner too. Real disasters are messy. They contain contradictory witnesses, incomplete weather reports, uncertain coordinates, maintenance problems, decisions that make sense only in the moment, and investigators who cannot always reach a final conclusion. Mystery stories work better when those complications are removed. Consider the missing DC-3 from 1948. The strongest version of the legend is an aircraft approaching Miami normally and then disappearing only a short distance from safety. The historical investigation is less simple. The aircraft had departed San Juan after problems with its batteries and radio equipment. Investigators also considered whether changing winds could have moved it away from the position its crew believed it had reached. Remove those details, and the disappearance becomes almost impossible. Restore them, and it remains unsolved, but no longer without context. Marine Sulphur Queen changed in much the same way. A tanker vanished without explanation is memorable. A converted tanker carrying thousands of tons of molten sulfur with a history that included fires and other safety concerns. Traveling through difficult conditions is a harder story to compress into one sentence. The ship is still missing. The 39 men aboard are still dead. The exact cause is still uncertain. But uncertainty is not the same as an absence of plausible causes. Flight 19 may be the clearest example of what happens when a complicated historical event is repeatedly retold. The original radio record is incomplete, and some phrases commonly associated with the flight entered popular accounts later or became more dramatic in retelling. The core story needed little embellishment. 5 Navy aircraft became lost. Their leader was confused about position, the formation failed to return, and no confirmed wreckage has been recovered. Yet once the flight became the central event of the Bermuda Triangle, every strange detail gained value. Confusion could become instrument failure. Instrument failure could become magnetic disturbance. An uncertain ocean could become a strange-looking ocean. The story slowly shifted from pilots struggling to locate themselves into aircraft encountering a place that did not behave normally. Then a librarian named Larry Couchet began doing something surprisingly damaging to the legend. He looked up the original records. Couchet worked at Arizona State University, where people frequently asked the library for information about the Bermuda Triangle. He initially approached the mystery with curiosity rather than with a mission to destroy it. But when he began comparing famous accounts with newspaper archives, official reports, and contemporary weather records, he repeatedly found differences. His research eventually became the 1975 book, The Bermuda Triangle Mystery, Solved. The importance of Couchet's work was not that he found one simple explanation for every missing vessel. He didn't. Instead, he questioned whether there was one mystery to solve at all. Some incidents had been reported inaccurately. Some had happened in bad weather, despite later claims of calm conditions. Some occurred outside commonly drawn versions of the triangle. In other cases, important details from official investigations had disappeared as the stories were repeated. A few cases remained genuinely unresolved, but unresolved cases exist throughout the world's oceans. This changed the problem completely. Imagine starting with 20 accidents and assuming they are connected. You naturally begin searching for one cause powerful enough to explain all 20. But if the boundaries were drawn after the accidents, some cases were inaccurately described, and each event has its own circumstances, the need for one cause disappears. You no longer have one enormous mystery. You have a collection of maritime and aviation accidents, some understood, some partly understood, and some still unknown. That does not make the individual stories less important. In some ways, it makes them more interesting, because we can finally examine what actually happened, rather than forcing each one into the same legend. Cyclops deserves to be understood as a Navy ship carrying an unusually dense cargo during wartime, with sister ships that later disappeared under strangely similar circumstances. Flight 19 deserves to be understood through the decisions of the men in those cockpits, the limitations of 1945 navigation, and the terrifying consequences of becoming uncertain over open water. Marine Sulphur Queen deserves to be understood through the condition of the vessel and the risks of its cargo. Turning all of them into evidence for one mysterious zone removes the very details that might help explain them. Yet the Bermuda Triangle survived Couchet's investigation. In fact, it survived decades of criticism from scientists, historians, the Coast Guard, and other researchers. That may be because a legend this powerful does not depend only on whether its original claims survive fact-checking. By the time people encounter the Bermuda Triangle today, many already know the basic story before they know any individual case. The name comes first. The disappearances are then interpreted through it. A missing ship becomes a Bermuda Triangle ship. A navigational problem becomes a Bermuda Triangle navigational problem. The geography gives unrelated events a shared identity, and that is perhaps the greatest reversal in the entire story. The Bermuda Triangle did not create the disappearances that made it famous. The disappearances created the Bermuda Triangle. Human beings drew lines around them later, gave the region a memorable name, repeated its best stories, removed some inconvenient details, added new mysteries, and eventually turned an unofficial area of ocean into one of the most recognizable places on the planet. But there is one test that storytelling cannot answer. If those lines really surround a uniquely dangerous part of the Atlantic, then the effect should exist outside books and television. Ships and aircraft should disappear there at an unusual rate. There should be something measurable beneath the reputation. And after more than half a century of arguing about the Bermuda Triangle, that question may be the most important one of all. When we stop counting stories and start looking at risk, is this part of the ocean actually more dangerous than anywhere else? If the Bermuda Triangle is a real phenomenon, this is where the idea should become strongest. Stories can be exaggerated, witnesses can be mistaken, individual wrecks can remain undiscovered, but across decades of ships and aircraft moving through the same region, an unusual danger should eventually leave a pattern. The difficulty is that measuring that pattern is much harder than counting famous disappearances. Before asking how many vessels have been lost inside the Bermuda Triangle, we would first need to decide exactly where the Bermuda Triangle begins and ends. There is no universally accepted answer. The familiar version connects Florida, Bermuda, and Puerto Rico, but different writers have moved those lines, expanded the area, or used different points entirely. NOAA does not recognize the Bermuda Triangle as an official geographic name, and the US Board on Geographic Names does not maintain an official boundary for it. That immediately creates a problem for anyone claiming a precise accident rate. If the study area changes depending on who draws the map, then the number of accidents inside it changes too. The next problem is even more important. Knowing how many ships or aircraft were lost tells us almost nothing unless we also know how many passed through safely. Imagine two stretches of ocean. 10 vessels disappear in the first, and 2 disappear in the second. At first glance, the first appears 5 times more dangerous. But suppose 1,000,000 vessels cross the first route, while only 1,000 cross the second. Suddenly, the raw number of disappearances tells a completely different story. This is the denominator problem, and it matters enormously here, because the Western Atlantic is not an isolated corner of the planet. It contains heavily traveled sea and air routes, connecting the United States, the Caribbean, Central and South America, Bermuda, and routes extending across the Atlantic. Florida alone creates enormous commercial and recreational traffic. Cargo ships, tankers, cruise ships, fishing vessels, private boats, and military vessels move through these waters. Above them, commercial airliners cross the same broad region constantly. A large number of incidents occurring in a heavily traveled area is not automatically evidence that the area itself is unusually dangerous. What matters is whether losses occur more often than we would expect after accounting for the amount and type of traffic, weather, vessel condition, and other ordinary risks. And this is where the official view of the Bermuda Triangle becomes surprisingly unambiguous. NOAA states that there is no evidence that mysterious disappearances occur with greater frequency in the Bermuda Triangle than in any other large, well-traveled area of ocean. The United States Coast Guard takes essentially the same position. It does not recognize the Bermuda Triangle as a specific hazardous region, and has said that reviews of losses in the area have not identified extraordinary factors. This does not mean NOAA or the Coast Guard claims to know exactly what happened to Cyclops, Flight 19, or every other missing vessel. Those are separate questions. It means investigators have not found evidence that the region as a whole behaves like a unique disappearance zone, and that distinction is crucial. We can have genuinely unexplained accidents without having an unexplained geographic phenomenon. If 10 mysteries occur across a sufficiently large and busy part of the ocean over many decades, some may remain unresolved simply because maritime and aviation accidents do not always leave enough evidence for investigators to reconstruct them. The Bermuda Triangle argument requires something more. It requires those mysteries to happen here unusually often. Establishing that becomes even more difficult when we ask what counts as a mysterious disappearance. Does a ship qualify if debris was recovered but the exact cause of sinking was never determined? Does an aircraft count if investigators believe fuel exhaustion is likely but cannot find the wreck? Should a vessel with known structural problems be included? What about a ship lost during severe weather? If every accident without a proven final sequence is classified as unexplained, the category becomes enormous. If only events with no plausible conventional explanation are included, it becomes much smaller. Different books have effectively answered that question differently, which is one reason lists of Bermuda Triangle incidents rarely contain exactly the same cases. There is another statistical problem hiding inside those lists. Imagine drawing a triangle on a map and collecting every unusual event that happened inside it. Then imagine finding an especially compelling disappearance just outside the line. If the triangle has no official boundary, the temptation is obvious: enlarge the region. Once the boundaries can move to accommodate the evidence can no longer independently prove that the boundaries identify something unusual. The map begins following the stories, instead of the stories testing the map. This helps explain why some accounts describe the Bermuda Triangle as roughly 500,000 square miles, while others give it a substantially larger reach. There is no instrument in the ocean showing where the mysterious zone ends. The borders exist because writers drew them. Then human psychology adds another layer. Once a place becomes famous for a particular kind of event, we become much better at noticing events that confirm its reputation. Psychologists call one part of this confirmation bias the tendency to notice, remember, or favor information that supports an existing belief. The Bermuda Triangle provides an almost perfect environment for it. Suppose a small aircraft disappears between Florida and the Bahamas. The location itself becomes part of the headline. It happened in the Bermuda Triangle. The new disappearance is added to documentaries, websites, and lists of earlier cases. Now suppose an aircraft disappears over another large area of ocean, with no famous mystery attached to it. Investigators still search. Families still lose people. The event may remain unsolved, but culturally, it stays what it originally was: a missing aircraft. It does not automatically become another chapter in a century-old legend. Over time, that difference in attention creates the impression of clustering. We repeatedly hear about unresolved accidents inside one named region, while similar events elsewhere remain disconnected from one another. The triangle becomes a filing system for mysteries. Every new case strengthens the folder because the folder already exists. There is also what researchers call selection bias. The cases remembered most strongly are not a random sample of every journey through the region. They are the extraordinary ones. Nobody writes a best-selling chapter about the thousands upon thousands of aircraft that cross the Western Atlantic and land exactly where expected. A cargo vessel traveling safely from the Caribbean to the United States produces no mystery to preserve. Those journeys are statistically essential but narratively invisible. The successful crossings disappear from the story, leaving only the disappearances. Seen that way, the Bermuda Triangle can create a powerful illusion. Picture an enormous map covered with millions of journeys. Nearly all of them end normally. Now erase every successful journey and leave only the accidents. Then circle several of the unresolved ones, connect them with lines, and tell their stories for 70 years. The resulting map would feel dangerous even if the underlying risk were ordinary for a heavily traveled ocean. None of this means the Atlantic itself is safe. Hurricanes are dangerous. The Gulf Stream can complicate sea conditions and searches. Reefs have wrecked ships. Navigation errors have killed crews. Mechanical failures happen far from land. Small boats can disappear quickly in bad weather. Deep water makes wreck recovery difficult. The region contains genuine hazards, just not evidence of one special hazard requiring the Bermuda Triangle as an explanation. This may be why the legend remains so difficult to kill. Debunking a supernatural triangle does not make its individual stories disappear. Cyclops is still missing. Flight 19 has still not been conclusively located. Star Tiger and Star Ariel still carried real people who never returned. There are unanswered questions inside these cases, and unanswered questions naturally keep curiosity alive. But the numbers force us to separate two ideas that popular culture has spent decades combining. An unexplained disappearance is evidence that we do not know exactly what happened to one vessel. It is not automatically evidence that the place where it disappeared causes unexplained disappearances. To demonstrate that, we would need a consistent region, consistent definitions, reliable traffic data, and a statistically unusual rate that remains after ordinary factors are considered. No authoritative investigation has established that pattern for the Bermuda Triangle. The pattern we can see clearly is cultural. Once the triangle became famous, accidents inside its flexible borders gained a second identity. They were no longer only maritime or aviation incidents. They became Bermuda Triangle incidents, and that label ensured that generations of people would continue hearing about them together. Yet something fascinating happened after the legend reached its height in the 1960s and 1970s. The ocean did not change, but our ability to move through it did. Pilots gained satellite navigation, capable of showing their position almost continuously. Ships gained GPS, modern radar, satellite communications, and increasingly sophisticated weather information. Meteorologists gained satellites capable of watching hurricanes develop across the Atlantic. Emergency beacons could transmit distress information and positions. Search teams gained better drift models, sonar, and underwater vehicles. An aircraft crew no longer had to look at a chain of islands and wonder whether they were seeing the Florida Keys or the Bahamas. A ship in trouble could increasingly leave behind something earlier generations often could not: a precise electronic trail. And if the Bermuda Triangle's reputation was built partly in the gaps between an accident and the evidence left behind, modern technology was about to make many of those gaps much smaller. The Atlantic did not become safer because the Bermuda Triangle became famous. What changed was our ability to know where we are, what is approaching us, and where to begin looking when something goes wrong. Put a modern aircraft on the same training route flown by Flight 19, and the difference is enormous. The crew can see its position continuously through satellite navigation. The aircraft's computers know its track across the ground, its speed and its relationship to the route ahead. Air traffic controllers can follow flights across areas that would have been far more difficult to monitor in 1945. Weather radar can reveal dangerous thunderstorms before the aircraft enters them, while satellites observe weather systems across huge areas of the Atlantic. A pilot looking down at a chain of islands no longer has to rely entirely on recognizing their shape and combining that observation with a compass, clock, and estimated wind. The aircraft can know, within meters, which islands they are. That single change removes one of the most frightening possibilities in the Flight 19 story: being able to fly perfectly while becoming increasingly uncertain about where the flying has taken you. At sea, the transformation is just as dramatic. A modern ship traveling from the Caribbean toward the United States can use GPS to establish its position continuously. Radar reveals other vessels, coastlines, and weather around it. Electronic charts place the ship directly onto a digital map. Many commercial vessels transmit information through the Automatic Identification System, or AIS, allowing other ships and shore stations to receive details such as identity, position, course, and speed. In busy waters, a vessel is no longer simply a small object disappearing beyond the horizon. It can leave an electronic trail. That would have been almost unimaginable aboard Cyclops. In 1918, once the ship moved beyond direct observation, information about her depended largely on reports, scheduled arrivals, and radio communication where available. When Cyclops failed to reach Baltimore, investigators did not have a stored satellite track showing her final movement across the Atlantic. There was no digital point where a screen could show that the ship had stopped. Her last known movements left an enormous amount of ocean between what was known and what had happened. Today, even the weather surrounding a voyage can be understood in a way earlier crews could never have imagined. Satellites watch cloud systems developing thousands of miles from land. Meteorologists track tropical disturbances while they are still far out over the Atlantic. Hurricane hunter aircraft can enter tropical cyclones and measure their winds and pressure directly. Ocean buoys provide observations from the surface. Computer models calculate possible future tracks. A hurricane that might once have appeared to a ship as falling pressure, increasing swell, and a darkening horizon can now be followed for days before its strongest winds arrive. Forecasting is not perfect, and hurricane tracks can still shift, but the crew has access to something earlier generations lacked, a view far beyond the horizon. When trouble does happen, another technology can change the search before rescuers have even left shore. Modern emergency beacons can transmit distress signals through satellites. On ships, an emergency position indicating radio beacon, or a PERB, can provide rescuers with identification information and, on GPS-equipped units, a highly accurate location. Aircraft have related emergency locator systems. The International Satellite-Aided Search and Rescue Network, known as COSPAR's SARSAT, receives distress signals and helps route alerts toward rescue authorities. The difference becomes clear if we imagine this technology aboard some of the vessels we have already followed. If Cyclops had transmitted an accurate distress position immediately before sinking, the mystery would be completely different. Searchers could have concentrated on a much smaller piece of ocean. Even if the ship went down too quickly for anyone to escape, investigators would at least know where to begin looking for the wreck. If Flight 19's aircraft had continuously transmitted modern GPS positions, Taylor's mistaken understanding of his location might never have become catastrophic. Ground controllers could simply tell the formation exactly where it was, and if an aircraft eventually ditched, its final track could narrow the search from hundreds or thousands of square miles to a far more manageable area. Search and rescue itself has become increasingly scientific. Instead of simply beginning at the last reported position and expanding outward, planners can use information about winds, currents, and the drifting characteristics of different objects. A life raft catches the wind differently from a person in the water. Wreckage, partly submerged, behaves differently from something floating high at the surface. Computers can model those differences and estimate how the search area changes over time. Aircraft, helicopters, and ships can then be coordinated around probabilities rather than only intuition. But modern technology has not removed the fundamental problem we encountered earlier. All of these systems work best when there is information to begin with. Lose that information and the ocean becomes enormous again. A distress beacon can fail to activate. A vessel may sink too quickly for a useful transmission. AIS can be outside reception coverage, switched off, lost with electrical power, or provide only the last point before something happened. An aircraft can still disappear in circumstances where its final position remains uncertain, and once the search area becomes sufficiently large, even 21st century technology begins fighting the same problem earlier searchers faced. There is simply too much ocean. What has changed most dramatically is what we can do once the search moves below the surface. Earlier investigators searching for a wreck in deep water had very few practical options. Divers are limited by depth. Cameras cannot simply see through kilometers of dark seawater. Modern oceanographers instead use sound. Multi-beam sonar sends sound pulses toward the seabed and measures the returning echoes, allowing a ship to build detailed maps of underwater terrain. Side-scan sonar can reveal shapes lying on or protruding from the bottom. Autonomous underwater vehicles can travel closer to the seabed and survey areas in remarkable detail. Remotely operated vehicles can descend into complete darkness, carrying cameras, lights, and instruments, while being controlled by people aboard a ship kilometers above. When sonar finds something interesting, an ROV can approach it. At first, the object may be only an unusual shape. Then lights illuminate steel. A propeller appears. A section of hull emerges from the darkness. Details that have not been seen since a ship sank decades earlier can suddenly become visible again. This technology has helped locate wrecks once considered effectively lost, including vessels lying at extreme depths. But it has not made deep-sea exploration easy. A sonar system still has to pass close enough to detect its target. Searching an unknown location means surveying the seabed in strips, traveling back and forth while gradually filling an empty map. If the wreck lies somewhere inside 10 square miles, that is one problem. If it could lie anywhere across tens of thousands of square miles, it is a completely different one. This is why Cyclops could still be waiting on the Atlantic floor, despite being more than 500 feet long. The technology capable of recognizing her may exist. The coordinates needed to put that technology directly above her do not. Flight 19 presents the same challenge on a smaller physical scale, but across a potentially enormous search area. Even if an underwater vehicle could identify an Avenger sitting on the seabed, researchers first have to find the right Avenger among a region where many military aircraft were lost during decades of training. Technology has made answers possible. It has not made them automatic. And modern disasters remind us that this is not merely a problem belonging to 1918 or 1945. Ships still founder, aircraft still crash into the ocean, storms still exceed forecasts or change unexpectedly, equipment still fails. Human beings still misunderstand information, make wrong decisions, and sometimes continue with those decisions until the opportunity to recover has disappeared. The ocean remains capable of breaking enormous machines and hiding what remains. What technology has done is close many of the gaps in which mystery once grew so easily. A modern voyage can leave behind GPS positions, radar tracks, satellite observations, radio recordings, AIS transmissions, weather data, and emergency signals. Investigators can reconstruct events minute by minute in ways that would have been impossible when Cyclops sailed from Barbados. They can know where a storm was, how strong the wind became, what direction a vessel was moving, and sometimes the precise moment communication stopped. This changes the Bermuda Triangle without changing a single wave inside it. The Gulf Stream is still moving. Hurricanes still cross the western Atlantic. The Puerto Rico Trench is still more than 8 kilometers deep. Reefs still surround Bermuda and the Bahamas. The Sargasso Sea is still held together by currents rather than coastlines. What has changed is the amount of darkness between the last thing we know and whatever happened next. And perhaps that is why the golden age of the Bermuda Triangle belongs so naturally to the 20th century. It existed at a remarkable point in history, when ships and aircraft were advanced enough to travel enormous distances across the ocean, but our ability to follow them, forecast everything around them, and search the deep sea floor had not yet caught up. Machines could disappear beyond the horizon faster than evidence could follow them. When they failed to return, there were sometimes only fragments left behind, a final radio message, an estimated position, a weather report, a few pieces of debris, or nothing that could be confidently identified at all. Today we can fill many of those gaps, not all of them. And that difference brings us back to the question hidden beneath every disappearance, every theory, and every line ever drawn across the western Atlantic. If the Bermuda Triangle is not an official geographic region, if its boundaries move depending on who draws them, if its compasses do not possess a unique, mysterious behavior, if its famous accidents appear to involve different circumstances, and if no unusual concentration of unexplained disappearances has been established, then what exactly have we been investigating all this time? And that may be the most important thing modern science has changed about the Bermuda Triangle. It has not given us a single answer, because there was probably never a single question. The name encouraged generations of people to look at this enormous part of the Atlantic as though one hidden force must connect everything that happened inside it. But return to the individual stories now, after everything we have seen, and they no longer fit together so neatly. USS Cyclops leaves Barbados in 1918, carrying thousands of tons of manganese ore and 306 people. She never reaches Baltimore. There is no confirmed distress call, no confirmed wreck, and no surviving witness who can tell us what happened. More than a century later, the final hours of that ship remain unknown. But unknown does not mean without context. We know Cyclops was heavily loaded. We know there were concerns surrounding the vessel and its machinery. We know two of her sister ships, Proteus and Nereus, later disappeared while carrying similarly dense ore cargoes. Structural failure, cargo problems, and severe sea conditions are not exotic ideas invented to explain away a mystery. They are physical possibilities suggested by what is known about the ships themselves. Yet without Cyclops on the seabed in front of investigators, there may never be enough evidence to choose one sequence with certainty. That uncertainty is real. It deserves to remain real. Now return to December 1945. 5 Avengers leave Fort Lauderdale and head east on a routine training exercise. Their leader becomes uncertain of his position. Islands below appear to him to be one place when they were probably another. Other pilots seem to question the route. Radio stations on land try to help. The weather worsens. Daylight fades. Fuel continues to burn. Eventually the voices stop. The aircraft are still missing, but we no longer need the compass needles to spin wildly, or the Atlantic to open beneath them. The more unsettling possibility is also the more human one. The instruments may have been capable of giving useful information, while the mental picture being built from that information was wrong. Once a navigator becomes convinced he is somewhere he is not, a rational decision can carry him farther from safety. The next decision is then made from a position that is even less certain. Error compounds until the geography inside the cockpit no longer matches the geography outside it. Then the ocean takes over. If the Avengers ran out of fuel and entered rough water after dark, the place where they crashed did not remain marked. Engines and heavy components sank. Lighter wreckage could drift. Wind and current began separating evidence almost immediately. The Gulf Stream continued moving north whether anyone was lost in it or not. Searchers arrived with incomplete information about where the aircraft had gone, and beneath them were thousands of square miles of Atlantic. That same current, so often presented as part of the mystery, now looks different too. It is not a supernatural river carrying vessels into nowhere. It is something more interesting, part of an enormous planetary circulation system, moving heat and water through the Atlantic, while also complicating navigation, waves and search operations. The storms look different as well. Bad weather no longer means a convenient explanation added afterward. We have seen how wind can oppose current, how waves grow, how squalls can erase visibility, and how an already vulnerable vessel can meet conditions that expose its weaknesses. We have also seen why that cannot simply be pasted onto every unsolved case. Star Tiger encountered difficult winds. Star Ariel apparently did not encounter the same circumstances. Marine Sulphur Queen had serious questions surrounding the vessel and its cargo. Witchcraft disappeared astonishingly close to Miami. Different events demand different investigations. Even the theories that grew around them contain pieces of real science. Methane hydrates exist beneath parts of the world's oceans. Rogue waves exist. Earth's magnetic field varies. Waterspouts exist. Hurricanes can produce astonishing seas. The mistake comes when the existence of something is treated as evidence that it caused a particular disappearance. A mechanism can be physically possible and historically unsupported at the same time. Science has to preserve that difference, even when certainty would make a better story. And then there are the explanations that move beyond established evidence. Atlantis beneath the Bahamas, electronic fog bending time, extraterrestrial intervention, portals carrying ships and aircraft somewhere else. These ideas became part of the Bermuda Triangle because the missing evidence created room for them. If there is no wreck, almost anything can be imagined in the space where the wreck should be. But absence does not allow every explanation to become equally likely. Extraordinary mechanisms require evidence of their own, and none has been demonstrated as a force responsible for disappearances across this region. By the time we reach the books and magazines that gave the triangle its name, another part of the mystery becomes visible. Cyclops did not enter the Bermuda Triangle in 1918. There was no Bermuda Triangle to enter. Flight 19 did not take off in 1945, knowing that it was flying into the world's most notorious patch of ocean. The shape came afterward. Writers collected accidents that had occurred in different years under different conditions, drew boundaries around them, and gave the collection a name powerful enough to change how every earlier event would be remembered. Then the story began selecting its own evidence. A disappearance inside the famous region became another Bermuda Triangle mystery. A comparable disappearance elsewhere remained an aviation accident or maritime loss. Details that made cases complicated could fade through retelling. The mysterious parts survived because those were the parts people remembered. And still, after removing all of that, something remains. Cyclops is still missing. Flight 19 is still missing. Families really did wait for people who never returned. Search crews really did fly over empty water, looking for wreckage that they could not find. Investigators really did close cases without knowing the exact final sequence. The failure of the supernatural explanation does not erase the historical mystery. It separates two claims that should never have been treated as the same. There is no accepted evidence that one unique force inside the Bermuda Triangle causes ships and aircraft to disappear. But there are individual disappearances inside this part of the Atlantic that remain unresolved. Both statements can be true. Perhaps some will eventually be solved. Somewhere on the Atlantic floor, the hull of Cyclops may still contain evidence of how she died. Somewhere beneath sand or sediment, an Avenger from Flight 19 may still carry identifying marks. Modern sonar and underwater vehicles can reach places investigators in 1918 or 1945 could barely imagine exploring. But finding those wrecks requires knowing where to look, and that may be the one piece of information technology cannot recover from the past. The coordinates may simply have died with the people aboard. That is where the Bermuda Triangle becomes more interesting, not less. The real mystery is not a perfect triangle where the laws of nature stop working. It is what happens when real danger meets incomplete information across an enormous ocean, and then human beings try to turn the fragments into a story. The Atlantic provides the storms, currents, deep water, and distance. Machines provide their weaknesses. People provide decisions, mistakes, and courage. History leaves gaps, and into those gaps we place explanations. For decades, the most famous explanation was the Bermuda Triangle. Science has gradually shown us something richer. There was never one mystery hiding inside those three lines. There were many. Some have ordinary answers, some have probable answers, some may still be waiting on the seafloor, and a few may remain unanswered forever. Not because something impossible happened there, but because the ocean took the evidence before anyone knew where to look. And somewhere beneath all of it, the evidence may still be there. Right now, a cargo ship can leave the Caribbean and move north toward the United States, with its position followed by satellites and navigation systems that sailors a century ago could hardly have imagined. Far above it, an airliner can cross the same stretch of Atlantic while passengers look down through the windows and see almost nothing but blue. The pilots know where they are. Controllers know where they are. Weather systems hundreds of miles ahead have already been observed from space. To someone traveling through these waters today, the Bermuda Triangle can feel remarkably ordinary. Yet beneath the ship, beneath the aircraft, beneath the sunlight reaching into the first clear layers of water, the Atlantic still becomes a world almost completely removed from the one above it. The continental shelf falls away. Canyons and slopes descend into darkness. Around the Bahamas, brilliant shallow banks end beside deep channels. Farther east, the seafloor lies thousands of meters below the surface. Near Puerto Rico, the Atlantic plunges into its deepest trench. Across this enormous landscape are wrecks from centuries of human travel, merchant ships, warships, sailing vessels and aircraft, some identified, some barely recognizable, others still undiscovered. Somewhere among them may be USS Cyclops. More than a century after 306 people disappeared with her, we still cannot point to a place on the seafloor and say this is where her voyage ended. If the wreck is eventually found, perhaps its structure will preserve enough evidence to support one of the explanations investigators have considered for generations. Perhaps the hull failed. Perhaps the dense manganese cargo played a role. Perhaps several ordinary problems combined into one extraordinary disaster. Or perhaps the wreck will create new questions. Somewhere else may lie the Avengers of Flight 19. Their discovery would not require the Bermuda Triangle to surrender some supernatural secret. A serial number, an identifiable component, the position of a wreck, something small could finally connect an aircraft on the seabed to 5 planes that left Fort Lauderdale in December 1945. We might learn where the formation ultimately went. We might discover how far Taylor's navigation error carried them. But even then, The seafloor could probably never tell us everything that happened inside those cockpits as daylight disappeared and fuel ran low. Some information does not sync with a wreck. It disappears with the people who experienced it. And this is the part of the story that no theory can completely solve. We tend to imagine mysteries as puzzles with answers waiting to be uncovered, as though enough research must eventually reveal the missing piece. History is not always that generous. Evidence corrodes. Records are incomplete. Witnesses die. Wreckage moves or becomes buried. Positions were never recorded accurately in the first place. Sometimes the final answer existed for only a few minutes, in the machinery of a failing ship, in the instruments of an aircraft, in the decisions of a crew, and then vanished before anyone could preserve it. That does not make what happened impossible. It makes it inaccessible. Above those lost places, the ocean continues without any awareness of the stories we have attached to it. The Gulf Stream still carries warm water north through the Florida Straits. Sargassum still gathers in the open Atlantic. Tropical storms develop, strengthen, and disappear. Waves cross boundaries that exist only on maps. Ships enter the region without feeling themselves cross into anything. Aircraft pass over its supposed borders without instruments suddenly changing. There is no line on the water between the ordinary Atlantic and the Bermuda Triangle, because humans created that distinction. Remove the triangle from the map, and Florida remains. Bermuda remains. Puerto Rico remains. The reefs remain, the currents remain, the storms remain, and the deep water remains. So do the unanswered disappearances. That may be why the Bermuda Triangle has survived every attempt to explain it. The legend was built around something genuinely powerful: our discomfort with incomplete stories. A ship leaves port and should arrive somewhere else. An aircraft takes off and should land. When it does not, we expect there to be a reason. When investigators cannot give us one with certainty, the empty space becomes difficult to accept. The Bermuda Triangle gave that empty space a name. For decades, it allowed hundreds of different questions to feel like one enormous mystery. But after following those stories back through the original accidents, the weather, navigation, oceanography, search technology, and the books that connected them, the mystery looks different. We do not need to choose between believing that the Bermuda Triangle possesses an unexplained supernatural force and pretending that everything inside it has been solved. Cyclops can remain genuinely unexplained without violating the laws of nature. Flight 19 can remain unrecovered while still having a plausible sequence of human disorientation, worsening conditions, and fuel exhaustion. There can be uncertainty without impossibility. A mystery is not evidence of the impossible. Sometimes mystery is simply the distance between what happened and what evidence survived. And in an ocean this large, deep, and constantly moving, that distance can become enormous. Perhaps one day sonar will find Cyclops. Perhaps an underwater vehicle will move through the darkness, and its lights will fall across an Avenger that has been waiting on the bottom since 1945. Discoveries like those could close questions that have remained open for generations. Others may never be answered, but either outcome leaves us with something more remarkable than the legend we began with. The Bermuda Triangle never needed portals, vanished civilizations, or a force unknown to science to become extraordinary. The real Atlantic was enough. It is an ocean capable of moving wreckage far from where it entered the water, hiding enormous ships beneath kilometers of darkness, building waves that earlier generations struggled to believe were real, turning small navigational mistakes into fatal distances, and preserving some secrets simply because the world above never learned where to search. The imaginary lines can disappear, the Atlantic remains, and the real ocean is deeper, more powerful, and far more complicated than the legend ever needed it to be.